Hello. A few days ago I debated Brian Leake on Modern Day Debates. I actually quite enjoyed it, and he seemed like quite a nice guy, even though he was pretty much wrong about everything. I thought I'd mirror it on here so you get a chance to watch it on my channel. I hope you enjoy. It's rather a long watch and there's rather a lot of stupid. Still, we've gotten used to that from flat earthers. So here we go, hand it over to Modern Day Debates. Thank you.
Welcome everyone to Modern Day Debate. We're a neutral platform welcoming everybody from all walks of life. If you're looking for even more juicy debates, don't forget to like and subscribe, including tonight's debate on Flat Earth with both of our interlocutors, Mr. Sensible and Brian, here to find us some answers. And if you like what either of them say tonight, both of our guest links will be in the description. And with that, I'm going to hand it over to Mr. Sensible for their 10 to 12 minute opening statement.
Lovely jubbly. Will I be able to go full screen?
Absolutely. Tell me when you start screen sharing. I'll switch you right over.
Oh, right. Well, I was just going to feed it straight through my camera.
Oh, sounds even better.
If you can just put me full screen. Okay, let me switch off my camera. Now, this debate was supposed to be about eclipses, stars, and pressure. So if we start off with eclipses, we all know what eclipses. It's when a solar eclipse, when the moon gets between the Earth and the sun. And if you're in the full shadow, in the umbra, you don't see the sun. If you're in the penumbra, you see a partial eclipse. When you're in a total eclipse, you see this. Basically, the entire disk of the sun is hidden. All you see is the outer corona, the atmosphere of the sun. Now, when you have the moon a bit closer, what you actually get is this, an annular eclipse. The moon is roughly 400 times smaller than the sun 400 times further away, but they're not always an exact match. When you do have an exact match with a total solar eclipse, then as the eclipse ends, you get this effect, Bailey's beads. It's the sun just starting to peek around the edge of the moon. The sun is shining through the valleys and between the mountains on the moon, showing that it is the moon that is eclipsing the sun. Because we also know that it's the moon that's in that location. Now, over the years, if you track the or map the path of the shadows, you get these. The blue are total solar eclipses, the red are partial solar eclipses. They all look in funny curved lines on this, as it's the globe, in effect, flattened out. When you look at that on a globe, they're nice lines. Eclipses can't work on a flat Earth. So the next thing Brian wanted to cover, I wasn't sure exactly what he wanted to cover, was, oh, come on. I'm seeing the wrong thing, I think, here. Wanted to cover was stars. I'm not getting the right thing coming up on my screen. Why isn't that appearing? I'm seeing the wrong stuff here. I think my OBS is screwed up. I might have to reload my OBS, which I really don't want to do. Ah, is that it? There we go. Stars. Here's the most famous constellation, Orion. A constellation is just a line of sight effect, just the stars appearing in some random pattern that we give a name to. The stars in Orion are not connected in any way, shape or form. Now, often people will say, well, if stars are moving, then the patterns of the constellations will change. They do. It's just the stars are so far away, it takes a long time to be noticeable. But the star with the greatest proper motion across the sky is Barnard's star. Here's a stacked image of it over 16 years. You can see that that star has moved. You can measure the distance to the nearest stars using a technique called parallax, like when you hold a finger in front of your eyes and you blink one eye, then the other. So if you take a baseline of the Earth in January and July, half the orbit of the Earth, you will see that that red star jumps against the background of stars. If you take a longer baseline, like they did with the New Horizons probe out past Pluto, you can either show a greater parallax on a near star, or you can start measuring parallaxes on further stars. New Horizons was so far out, it would get a parallax view of a star that's actually quite distant. When they did it, what they actually saw was this. It's the same star viewed from Earth and New Horizons. It jumps against the background because it's closer than the background. It's not some dome with lights on. The Chinese, Japanese, and astronomers in the Islamic world saw a new star in 1054. It was a supernova. When we looked at it with telescopes and good equipment, we found this, the Crab Nebula, the remains of that supernova. You can study the makeup of stars by studying the light. If you run the light from a star through a spectrometer and produce a spectrograph, you get one of these. It's the rainbow pattern of light split by a prism. The dark lines are Fraunhofer absorption lines. Every chemical element absorbs light at different wavelengths. So hydrogen will always have the same black bar and so on. So if you know what the patterns are, you can point that at different stars and work out what the stars are made of. And in fact, there's another effect, which is, if it comes up, there we go, redshift. As the further stars are away from us, the faster they're moving. The absorption lines are red shifted due to the speed of the recession of those stars. NASA took the Hubble Space Telescope and pointed it at an empty piece of space for days and days at a time, gathering as much light as they can. And they got this, the Hubble Deep Field View. Each of those dots is actually an entire galaxy, billions of light years away. It turns out that space is big, really big. I mean, you might think it's a long way down the road to the chemist, but that's just peanuts compared to space. Now, if the stars were rotating around us, those galaxies billions of light years away would have to be going rather fast to rotate around us. If you lock a camera onto one position in the sky and take I forgot what the word is, a delayed image or whatever you call it, you can see the effect of the Earth rotating rather than the stars. But let's move on to pressure, because I've got a lot to go through here. This is the Compass Tokamak fusion reactor. It's a torus, a donut shape with vacuum in it. They inject gas plasma, and powerful magnetic fields are used to hold that gas plasma in shape. That's why you can see the shape of it. A magnetic container is enough to hold gas in a vacuum. You certainly do not need a physical container. Now, I actually sent MAGE up high in the atmosphere under a weather balloon. This is MAGE. It's a probe sponsored by Bob the Science Guy, Arctic Haze, and Just Shoot Me. We had two wide-angle cameras, one pointing at the balloon, one pointing backwards to just get a great view, and a narrow-angle lens pointing forwards to those two strings. I think that's on the left for you, which are a reference frame. When MAGE went up there, we also had a temperature gauge and a pressure gauge. This was the pressure readings we took. At ground level, we had over 100,000 pascals of pressure. When we reached a peak at 38.75 kilometers, we had about 263 pascals of pressure. That's all. 99.7% of the atmosphere had gone. So let's have a quick look at MAGE. And I just realized I hadn't called up my, sorry, give me a few seconds. I had notes with it. Where is it? Here we go. So if I jump in at 4 minutes 15, had this graphic that's behind me supplied to me by an engineer in Chile, Andre Puelma. That curve is the calculated amount of curvature you should see above a globe Earth at a height of 39 kilometers. So if we jump forward and we can actually see the launch, here we go. Oh, I got the time wrong, 6:52. Here we go. So what we got in the top left is the balloon camera. Next to it, we've got the wide angle camera for the view. Bottom left, we've got the temperature, and next to it, we got the pressure readings. So if I jump forward now to the highest point we got to at 2045, see what happened then. Now that balloon is bursting because it's got the same amount of hydrogen it had all the way up at its pressure, but the external pressure, the atmospheric pressure, is virtually nil, and the latex of the balloon couldn't stand it anymore. That balloon tore at the speed of sound. And that little puff you can see at the top is actually the puff of the talcum powder that was inside the balloon. So if I jump forward to 3513, we see the best shot we got when we were up there, which was this. Between those two lines, which are strings that are held taut, you can see the curve of the Earth, which is exactly what we were going up there to look for. And we compressed it left to right, put a straight line on, and you can see the amount of curvature of that horizon. And if we jump forward again, we should see, if we overlay Andre Palmer's graphic over the top, his predicted graphic at 39 kilometers is a pretty good fit. Not exact, because this was only 35 kilometers. But of course, I'm not the only person who's been up there to look. We also got Felix Baumgartner. Let's see what he had to say. So I've talked about pressure, I've talked about stars, and I've talked about eclipses. I sent a camera up and filmed it. The Earth's a globe. I checked. Thank you very much, and I hope Brian has some evidence that he's going to bring to me. I don't know how I did for time.
No, that was perfect. About 8 or 9 minutes, right in there. Thank you so very much, Mr. Sensible. And with that, we're going to hand it over to Brian for his 10 to 12 minute opening statement.
Okay. Yeah, that was good. I want to open by saying Felix Baumgartner. I have a video I didn't put in my introduction, but showing the horizon at ground level, matching. I just left the horizon on the screen for their whole video. And as soon as he got up to altitude at about, I think it was between 20 and 30 miles, about 28 miles, the horizon matched exactly where it was on the ground. I need to share screen, please.
Sure. So switch into square screen mode, and I'll send it right over.
Can you put me on full screen?
Do you want to share screen, or do you want yourself to be on full screen?
No, I want to share my. I want to share my screen.
Yep. So share screen, and then once that happens, I'll be able to share it.
Okay, I just did that. And, I'm ready.
Yep. Still just seeing 3.
Okay, hold on.
No, you're good.
Okay.
And while he's setting that up, I will say send those questions in for our Q&A section if you would like to have your answers from either one of our 2 interlocutors. Oh, there we go. I'm starting to see something. All right. I'm going. There we go. Fantastic. And it's up on the screen. All you.
I'm still waiting to see it on YouTube.
There's a delay. Trust me, it's up there.
Okay.
All you. And if you want audio, make sure share audio is on.
Is there no audio being shared?
Not hearing audio, and I did for a half second see the share audio off button on.
Let me check again. Yeah, please.
Right at the bottom.
All right.
See if that fixes.
Earth. Georgia Institute
There
of
we go.
Technology on behalf of NASA. The model used is a flat, non-rotating Earth. Technical memo from the NASA Langley Research Center, flat, non-rotating Earth. NASA Technical Memorandum, flat, non-rotating Earth. NASA publication on the derivation and definition of a linear aircraft model, flat, non-rotating Earth, and flat, non-rotating Earth. NASA contractor, flat, non-rotating Earth, and flat Earth assumptions. NASA Ames Research Center, non-rotating flat Earth. Army Research Laboratory, flat Earth. Army Research Laboratory, propagation of electromagnetic fields over flat Earth. Army Research Laboratory, a flat Earth approximation provides the best estimate. NASA Technical Paper, stationary atmosphere over a flat, non-rotating Earth. NASA Technical Memo, a non-rotating Earth. MIT Department of Aeronautics and Astronautics, flat Earth, flat Earth. NASA memo, flat, non-rotating Earth. NASA contractor report, assumption based on the Earth is flat and non-rotating. NASA technical memo, flat, non-rotating Earth. NASA technical paper, stationary atmosphere and flat, non-rotating Earth assumptions. NASA technical note, flat, non-rotating Earth. NASA Langley Research Center, flat, non-rotating Earth. Army Research Laboratory, these equations assume a flat Earth. Even the Soviets made their assumptions based on a flat Earth. If the Earth were a ball and rotated at 1,000 miles per hour, you obviously would not see the repeated engineering assumptions that the Earth is flat and stationary.
One flight that should be a simple 11-hour shot across the Indian Ocean is from Johannesburg, South Africa to Perth, Australia. However, this flight takes a detour north, stopping in either Dubai, Hong Kong, or Malaysia to refuel, for a total flight time averaging over 18 hours. This ridiculously wayward detour is frustrating to say the least, but on the flat Earth map starts to make sense. Another.
So here's some examples of the local sun and a flat landscape. You see the hot spots, the local hot spots? My opponents attribute that to glare off of water. So I used examples here with multiple bodies of water. So even if it is glare off of the water, it's localized. So in the heliocentric model, the sun's 93 million miles away. Look at that. It certainly doesn't appear that way. And furthermore, look off in the distance. Forget the debate with the lens and the rectilinear and the wide angle lens. Look straight out ahead. There's supposed to be 50 miles of drop at that altitude. It's approximately 20 miles up. And according to the Earth curve math, there's supposed to be about 50 miles of drop straight ahead. If you look out straight ahead, it's flat as a pancake. The horizon's flat, and there's another example of a local sun. You see the hot spot. So I've gone to suncalc.org. This keeps track of where the sun is. Okay, let's check equinoxes. Let's see what model fits. Okay, so the vernal or spring equinox is said to happen on the 21st or 22nd of September. Okay, so here is September 12th. So you have 7:05 a.m. sunrise and 19:30 sunset. So that's 12 hours and 25 minutes. So that doesn't work, but we're not quite to the equinox. So let's take a look. Let's go to the 21st of September. Okay? Now we got 7:09 to 19:19. So that's 10 minutes off. Let's keep looking. Let's go to the 23rd of September. A little closer. 7:10 to 19:16. So that's 6 minutes off. Okay, let's keep looking. How about the 26th? How about the 26th? Sunrise, 7:12 to 19:13. That's within 1 minute.
Let him in.
And now, if you look
Right,
at
go in there, buddy. Go in there. Go in
the
there.
sun right here,
Come in.
it's setting. Okay, that's almost a perfect equinox, off by 1 minute. So sure, it's rising in dead east and setting due west. It's still spinning its circle, which is exactly what we would expect on a flat Earth, is it not?
Okay, one more thing. One more thing here.
think he's getting his one more thing, but in a few minutes we are about to move into open conversation, ladies and gentlemen.
Thank you very much.
Woohoo! All right. Thank you, Mr. Sensible and Brian, both for your opening statements. And with that, we are going to move into 60 minutes of open dialogue. Though if you guys have your burning desire questions, you're like, I really want to know that. Now is your time. Tag me or Modern Day Debate in chat, and we will send them in. But guys, the floor is all yours.
Thank you very much, Amy. Mr. Sensible, let me give a shout out real quick to David Caron. That's C-A-R-O-N for the awesome song. He's bomb. And Flat Earth Banjo, USA, Japan, Brazil. And Taboo Conspiracy. And if I missed you, I'm sorry. One thing I didn't get to was I wanted to show some star trails without wide angle lenses and how off in the distance, we see from the equator, we see the stars directly overhead going straight. We see the stars off to the right in the distance deviating to the left. Would you agree with that? And the stars to the right, like deviating toward what you would call the northern hemisphere? Would you agree with that?
I'm glad you've actually mentioned stars, Brian, because we were supposed to be talking about stars, eclipses, and gas pressure, and we saw absolutely none of that in your opening at all. But yes, if you're stood on the equator, the stars passing directly overhead will be going straight overhead. If you look to the left, they'll be rotating one way. To the right, they'll be rotating the other way. You agree with that?
Yeah, and that's all fine and dandy.
Except that it won't work on a flat Earth. Have you ever had an LP record, a vinyl record, yeah? It rotates around the hole in the middle. I would like to see you put another hole somewhere else and get it to rotate around both at the same time. If you can do that, I'll admit flat Earth.
Sorry, I got a little long on the video, too. I wanted to show gas pressure gradient and side containment, which I might have a chance to go shortly. I got a short clip. But so you agree that the stars are deviating off to the right to the southern hemisphere? There's a big problem with that. Yeah, you think, hey, that proves a globe. You know, the stars going around the northern hemisphere. But do the stars know what we're standing on? If I see stars deviating to the right and then deviating to the left, and I can put a ruler on that screen and measure actual separation, that's one of two things. Out there on the horizon, or a little above the horizon even, that's one of two things. That's actual star separation, Mr. Sensible. If one's going,
the stars are not.
Hold on. If one's going this way, one's going straight, and the other's curving that way, that's measurable. So I would attribute it to either actual separation, meaning more than one star rotation, at least three, if that's the case, or perspective. Neither one of them works for a globe. Perspective don't work for stars, and actual separation certainly doesn't work for stars.
Well, I showed you this clip of film, Brian. If you actually kept your head still, or your camera still, looking at a star, you'll see the stars are not moving apart. It's not like gears in the sky. It's like a wallpaper in your living room. There's a pattern there of the stars, and you're spinning round. The pattern on the wallpaper is not changing, it's not flexing, it's not moving apart or anything like that. Okay, so now those time-lapse photographs, as you mentioned, often using wide-angle lens, so you can see a wide part of the sky. So there is.
So now they're not deviating off to the right and the left. Okay, because just a minute ago I thought you said that they were.
They're rotating. They're rotating. Sorry. Go on.
Anyway, I almost played that exact clip. Shout out to Iro Landucci, who showed one of the pilots showed from Europe down to, I think it was Paris, down to Palo, down in South America, and it showed the stars moving, not the Earth. It showed, and what's even funnier than that, and I wonder why Globers don't use this as an argument. I would argue that, hey, if I get higher, I should be able to see, raise up and see more stars. But as he traveled south in that airplane, no more stars became visible. The whole sky deviated to the right.
I really don't know what you're talking about, but because what you'd have to explain is if you look towards the North Pole star, you will notice that the stars apparently are rotating around it. If you head south and look southwards, you'll see the stars are apparently rotating around Sigma Octantis. How can stars be rotating around 2 points on a flat disk?
I got to go back to.
Doesn't work.
Did you not agree that with a star trail shot from the equator, or either a little north or south, that the stars are deviating?
Perhaps it's the words. Perhaps it's the words you used and I misunderstood. What I would say is if I'm looking straight ahead, the stars will appear to be going straight over. If I look that way, they're going in an arc that way. If I look that way, they're going in an arc that way. They're not really going in an arc. You're just turning around.
Okay. But let me remind you, Mr. Sensible, if you're taking a time lapse, you cannot move the camera even a little bit, which is another problem for the globe. If you it would work on a globe. Everybody picture a table underneath a light straight ahead. Okay. And let's say in the center, directly underneath that light represents a camera. Okay. Now you spin that table representing the Earth. That would work just fine. Okay. But if you take that camera and you move it from directly underneath that star, once again, if you point it directly at the light, which I'm calling the star, and you spin the table, it'll work if you got it perfectly lined up. If you deviate,
are you talking about
directly overhead, representing Polaris, representing Polaris. Now, if you deviate from pointing the camera directly at that light, just off even a little bit, you start getting parallax. Once again, proven.
You wouldn't get parallax if you've got a flat table.
I got a video.
Yeah, but if you've got a flat table, you slide that camera across, that light will start to draw circles. That's not the same as the Earth, where you're actually going around a curve. But I need to pick you up on some of the things in your presentation. You use that 8-inch per mile thing about curve. That's just a rough guideline for a few miles. That is not the formula for Earth curve. That's the formula for a parabola.
A parabola up to about 1,000 miles. If you want to be technical, there's a couple different formulas we could use. The more common one.
We'd have to be technical because that won't fit against a quarter of a sphere. You also use taboo conspiracies.
Why would you say that? Do you know that matches the software? All the software. The 8-inch per mile squared matches
the curve calculators.
1,000 miles.
The curve calculators, the online curve calculators. Well, they don't use 8 inches per mile squared. However, for the first few miles, that's a rough approximation. So yeah, it's going to roughly match for a while, but it will get further and further away from the actual figures. But I want to pick you up on the taboo conspiracy thing where you showed all those NASA papers assuming a non-rotating Earth.
Well, no, there was only a couple of them from NASA, Mr. Sensible. That was
NASA and Air Forces.
Why would they classify just general?
If you let me finish, and perhaps I can make my point. You had a couple of NASA papers and other papers saying that we assume a non-rotating Earth. Now, if you had a ball and you were going to throw it and you wanted to calculate how far. Let's assume there's no wind, okay? Yeah? Right. You just assume, so there's never any wind. No, you just assume for that example, there's no wind. They assume for their workings in that paper that it's flat because it makes no difference. That's all. It's an assumption, a working assumption, just to make the calculations easier.
So it works just as well flat, and unless you want to project it on a globe, then you could do the math and convert it. We both know that. Okay. I want to get into one other thing. I did appreciate your maid video and sending that balloon up, but I thought, man, you had to dig through that video to find what you call curve, like a speck of curvature. If you look at all the high altitude, I mean, to me, your maid is a good demonstration of a flat plane straight out ahead. Like I said in the opener, it's supposed to be approximately up about 20 miles up. There's supposed to be approximately 50 miles of drop out at the horizon, which is supposed to be, I think, between 400 and 500 miles ahead, or 400 and 450. And we just don't see that. I mean, plus the 20 miles altitude of the balloon. So that would be about 70 miles of drop straight out in the distance. And while people are focusing on the left to right curvature, which I might add, I'll bring that up later, but that is arguably a circle of sight, which y'all use in some of y'all's arguments. But if you look straight out ahead, it looks like a flat plane up at that distance. I mean, can you at least concede to that it does look pretty damn flat out there in the distance? Would you completely?
Right, I'll make a couple of points. You said I had to dig around. Well, the actual full flight video is about 2.5 hours long. That's the shortened experimental video, and we wanted to get, or I wanted to get, a shot with that horizon sort of level and across the middle of the screen to reduce the chance of any distortion and have that as high as possible. Remember, it's dangling from a balloon, so it's swinging and it's rotating. So getting a good shot is tough, and it pretty much matched that calculated curve. You said about the drop away from you. Well, a couple of things. You're actually right. It's about 400 miles, but you've got foreshortening. As it goes around a curve, you think of things like railway sleepers. As they get further away, they look closer together. This is even worse because it's also going down. You're not going to see a degree or two drop by your eye looking straight forward.
It'd be 6 degrees.
Eyeballs swivel. You are drawn to look at the thing you're looking at. You're not going to notice and think, oh, I'm looking down, because you're looking down 1 or 2 degrees. You're not going to see.
On a globe at 125,000 feet, it should be a 6-degree drop, or approximately 125,000 feet. And once again, we don't see that. But I would agree that it varies with distance according to how far we could see for the day. I think that's what limits our vision. Y'all do have explanations for damn near everything, but 9 out of 10, so do we. We're still working on it. Even the Hercules, one more thing, the Hercules rocket went up and it showed down, and they started getting some good still shots at like a few hundred miles up, and it's the same thing we see in your Mage. If you want to compress it from left to right, you could probably get curvature, but we could attribute the lens. Look, one thing real quick. When we say, if you're looking out in the distance and you see an island, way out in the distance, 2 islands, and they're about 10 miles apart, okay? Or we see a boat crossing, and we say, okay, we watch the boat go from the right island to the left island, and it just goes straight across on a straight horizon, okay? But if we were behind that boat would drop to both observers, and that doesn't make sense. From what y'all attribute that to is the circle of sight. What I've heard before anyway is that say that it's a circle of sight. Why would that change up at 120,000 feet, Mr. Stinson?
I'm not quite sure what you mean. It sounds like Quantum Eraser's Alice and Bob silly argument. And maybe it isn't, but you really don't want to go there, because I've never seen such a ridiculous thing as
because y'all are looking on this. Well, you know there's a catch to that. You think he's that ridiculous, and I think you know better. Okay, because y'all are only looking on the surface of that argument. Okay, well,
no. If you're talking about Quantum Eraser, is that what? It is the most ridiculous argument. He's on the surface. Well, he's saying that if you've got Alice over here,
I know what he's saying.
But I'm telling other people who may not know.
Okay.
Alice over here, 20 miles away from Bob over here. As Alice looks towards Bob, there's a curve down. As Bob looks towards Alice, there's a curve down. So if they walk to each other, they go into an abyss. That is quite patently dumb. Sorry,
right,
it is
because
dumb.
On the surface level, if you want to think of it in a box, then you would think that's dumb. Shout out to Quantum Eraser, by the way. Okay, that same argument, okay, if you look at the big picture of what he's talking about, okay, if we get an orthographic view to Bob and Alice, once again, if we have an island 10 miles to the left of us, way out in the distance, and 10 miles to the right, we're going to watch Bob travel straight to Alice with no drop. But on the model, they're both dropping down because of angles. We understand that. The point is when we watch a boat go across the horizon from one island to another, we don't see that. Bob and Alice do not see that. That's the whole point of the argument, and everybody missed it.
No, because he actually said they're walking down into an abyss. Whatever you
It's a
may
joke,
think
though.
about whatever you may think about what he might have been saying, and I'll hold you with higher respect than Quantum and Razor, because he actually said they're walking down into an abyss. I really, for your own benefit, I wouldn't follow that line of argument.
Well, I'm just explaining it the way the flat earthers argue it. And you haven't heard the whole thing. It's a joke. Like on a globe, it'd be like a McDonald's sign, right? In other words, looking at Mage, you're showing a little bit of curve, especially if you compress it. You found a spot where you're showing curve right to left, right? That little bit of curve. But let's say if I turn to the right a few degrees, would it be like a rose petals? Would it be like just keeping on M and over? Let me ask one question real quick. Where was Mage? Where was it over roughly, just generally?
It was roughly over central England, and when it was at its peak, you could see across, because we know because of cloud patterns that we checked, or I checked against satellites, 3 independent satellites. It could see approximately 400 miles. It could see across the Irish Sea and into Ireland. It could see a darn long way. And
so would you say?
Sorry, you keep saying about this little bit of curve. Okay, I do need to stress a couple of things. With the compression, that accentuates any amount of curve, even if it's only slight. Straight lines would still remain straight. So if that horizon was straight, it would still look straight compressed. It may get pushed to an angle, but it would still be straight. Okay. And that was not the case.
Okay. Would you say that from central England, that central England is probably higher than like toward the sides of it? Like, wouldn't you agree that the middle of England, that it would have to slope off to its shorelines? I mean,
well, I don't know what the elevation was of the ground where I was when we either recovered Mage, or let's say we recovered it in the middle of England. Maybe it was a couple of 100 meters above sea level. That makes no odds.
It's more than that.
And see, the land may go down in a gentle slope to the sea at one place and finish in a sharp cliff at another place. What difference does that make?
I forgot. I wish I remember what Gleam said, but I would almost bet it's over a mile because it's fading off to the right. Now, let me ask you one question.
Mile? Okay? You're saying central England. Hold on. You're saying central England would be a mile above sea level. Those rivers are going to be rocked. The river, you could white water raft down the River Thames if that was the case.
Okay.
It's about 50 miles, and you think it's a 1 in 50 slope down.
Maybe I'm wrong about that. I would just think the center of England I would think it would slope down toward the coastlines. I could be wrong. Okay, but Mr. Sensible, you would agree that if there was an island off to the right, off the distance, and an island way off the distance to the left, that I would watch the boat go from island to island straight on the horizon. Would you not?
Are you talking about you being at sea level?
Yeah, like Bob Nodell, shout out to him from Globebuster. He gave an example.
Yeah, thanks, Bob. 15 degrees per hour.
Yeah. And he let out his data and showed that well, I don't want to change the subject just yet, but he proved the same thing as the Michelson-Morley, which is why y'all never really use it for proof. It doesn't prove one way or another. But check it out. If anything, it proves a flat Earth that there's something spinning. But wait, don't steal from the point. Point is, why is the boat from islands, 10 plus miles apart? Why am I seeing that boat travel from island to island straight across?
If you were stood on one, no, your islands. If you were stood on one of those islands, looking towards the other, how much drop would you think there is over 10 miles?
If I'm 6 feet tall, about 66 feet.
Okay, so if I'm stood at a distance where I can see 2 islands that are 10 miles apart, do you think I'm going to notice a hump in between of 66 feet? Your eyes are not that good.
Even if there was a little hump there, it would be part of a circle of sight, which is the same thing up at distance. Look, everything has a viewing radius. It's called a viewing radius. And like I said, if you wanted to attribute Mage to curvature on them edges, especially by compressing it, then basically you're making England a flower. Now, if you could get up so high as to see, if you could get up so high as to see, like if I'm in an airplane and I see the horizon out of the left window and the right window. Now, if you can get up high enough where the horizons start coming together, and you could see both horizons, I might take
So
that.
both horizons? I don't follow you, Brian.
Like if you could see, they only ever show one horizon. In other words, in an airplane, you could look out the right window, you see a horizon.
Okay.
You look out the left window, you see a horizon. If you get up high enough where they start coming together, it's probably about, I think it's about 22,000 miles is the height. So that's not realistic for what we're talking about, but that's how high you would have to get up to prove left or close to it to prove left to right curvature.
I'm not sure what you're talking about. I mean, let's just say for the sake of argument, you could stand on top of that aircraft. Okay, just for the sake of argument, if you look to the right, you see the horizon. You turn around, you'll just see the horizon all the way around at the same distance from you all the way around. It's not going to go down like that and then have to come up again, as you mentioned petals earlier on. That's
the whole problem, though, man.
That's just failing to visualize the three-dimensionality of it.
Every camera, though, has some level of barrel distortion.
No. Every camera, well, every camera does have a level of distortion. Can we just clear something up? I know you haven't said this, Brian, but many flat earthers will say, "Oh, that's a fisheye lens." That's a very specific lens. A fisheye lens is the ones that when they hold it up, it looks like you can see a whole world just below your feet. You get wide-angle lens, which will have still a large amount of distortion. Narrow angle, like I use, which will have absolutely minimal, and rectilinear, where it's even less. I used a narrow angle lens to keep any distortion to a minimum. I had physical strings in front, but even with that low distortion lens, there was a slight amount of distortion. Your problem is that the horizon line in that snapshot was in between those lines, so it cannot have more distortion than those lines. It was curved. That can't be the case if it was flat.
Camera, man. I'm having to use my phone, so it's a little bit shaky. I do apologize for that, man. I heard your little comment at the beginning. But I wanted to say one more thing. I think to be conclusive, Mr. Sensible, and this is being fair to both sides, I think we need to send up some better instruments instead of just a camera like a theodolite, because I'm going to claim that you did not have 6 degrees of drop. Well, I think it's about 5.5 degrees at the height you made it to.
Right.
I think to prove that, I think we need a type of theodolite app in our equipment. So to be fair, I'm gonna put that one. I'm gonna draw that one for now.
Well, what I'm going to say is we specifically were not looking to try and measure drop. So sometimes that camera was swinging up, swinging down, left, right, and all sorts. Okay. So from any image there is no instrumentation to say, right, you're hanging level right now. So you could not measure any drop. So you cannot conclude anything like that from it. It would be extremely difficult. But by all means, I would like to see a flat earther send up a weather balloon with instrumentation and do what I did, which was to make a launch to landing video uncut, showing my face as I launched it, my face as I picked it up, making that available on the internet, plus all of the telemetry data. And anyone can get that data. They can just email me, email me, Mr-Sensible@hotmail.com, and I will make that data available to them, as a number of people have been sent it. It's open to everyone.
I gave you 2 examples in my intro, the dog cam, and there's a couple. It's not mine, so like I said, I admire the fact you actually went out and did it. I actually have the balloon. I had 2 of them, but I wasted one of them. I found a way to get the gas. But I wanted to talk a little bit, speaking of gas, I wanted to share my screen, but I'm just going to describe this instead. If you don't believe me, you can go to my channel. It's pretty easy to visualize. A big topic in this argument is gas pressure inside containment. You just showed it with a magnetic field.
I did.
That, I'm good with it. A flat earth, it would be a magnetic field that would be containing it. But here's my point. Okay, so I got a video. I took about 70 foot of PVC pipe, real thin, about 1/2 inch, I believe it was. I connected it together and I wrapped it in a U to where both open ends of the long stretch of PVC pipe were right there at my feet. Okay, I took some gutter from roof, the gutter that collects your rain, and I put about 8 to 10 feet at the end of each pipe and submerged one end in boiling water, the other end in ice water, as cold as I could get it. I put a balloon. I left the pipe open-ended, and I loosened up 2 balloons, blew them up a few times and loosened them up, and I put a balloon on each end. You picturing this with me so far?
Yeah, but can you get to what it's supposed to show?
Yeah. So where it was hot on the boiling water side, in only 70 feet, I was able to show a pressure gradient, okay, from temperature, which I think gas law perfectly predicts, which is what we see in nature. It's hotter at the ground and cooler at, you know, up at altitude.
You're wrong. You're wrong.
Okay.
Okay. I forget the exact height measurements. Okay. But
it's not hotter at the ground level.
Hold on. Well, let me just tell you briefly. With Mage, we measured the temperatures at ground level. I think it was about 13, 14 degrees. As we went up to about 25,000 feet, it dropped and dropped to about minus 32. Then the temperature, you reach a temperature inversion layer as you get to the stratosphere, and the temperature started climbing. It actually climbed then to just above zero. I think about 2 or 3 degrees. So I'm afraid you're wrong. It gets colder as you got to a certain height, then it gets hotter, then it gets cooler again, then it gets hotter yet again, or warmer yet again. And eventually you reach the thermosphere. So I'm sorry. I mean, I do know what you're saying.
Gradient. No pressure gradient. Okay.
Oh, absolutely, there's a pressure gradient. I showed you that graph of a pressure gradient. Let me just pull it back up on.
You're saying there's not. You're saying it varies.
No, I'm not saying that. There's no. It's the temperature you were just talking about. Here's the pressure gradient starting on the left. Starting on the left, it's a flat line because that was just at ground level. Sorry, starting on the right, beg your pardon, because I've got the screen flipped. It's over 100,000 pascals of pressure. That's 14.7 psi, 760 torque, approximately. It drops as we go up in a nice, gentle curve until where that blue line crosses it and there's a red dot, that was the peak of Mage. And at that point, there was only 263 pascals of pressure. So we got a nice gradient going down from 100,000 to 263. Nothing, no containers prevented that 100,000 rushing up and trying to equalize with the 263, apart from gravity.
So the temperature is not playing the biggest role in refraction.
No. In what? In what? Refraction, did you say? Or the temperature is not.
That would work out perfect. Hold on. That would work out perfect on a flat Earth, because way off in the distance, when we see the sun set, which if it's setting about 6,000 or 6,200 miles away, and that's if you do the math with a little bit of a refraction, that's about the angle we would have is maybe even a little greater. But
that was pressure gradient, Brian. That was pressure gradient.
Let me make my point though. That's where we start. You said an inversion layer. That's right where we see the sun.
Temperature inversion. Oh, right. Okay. Yeah. So go and carry on.
Yeah. So we start to see the sun doing funny things on the horizon, and people would be surprised. But if you go out to see a sunset, you don't just see the sun go by on the horizon very often. It's a few times a month. Give or take. You might go a month and never see the sun go behind the horizon. There's a cloud deck more often than not there. And when there is a clear horizon, you start getting funny things like Fata Morgana looking effects, and that would have to be due, in my opinion, to a inversion layer.
Well, then you're going to have to explain how the sun that is at whatever height above the ground, how the sun can shine on the bottom of clouds, how the sun can light up the tops of mountains first thing at dawn before the bottoms of the mountains. And as sun sets, the bottoms of the mountains go into shadow before the top. Okay. You're going to have to explain how you can go to Dubai, stand at the base of the Burj Khalifa, see the sun set, race up in one of their super fast elevators to the top, and see the sun set again. Let's
do that with math. Okay, so how high would the horizon be from the one particular video? They showed like about a 20-story building that's about, I don't know, a couple hundred feet. So that horizon would have to be, what's this 1.22 times the square root of, I'll make this quick. Let's just say the square root of 36. Okay, no. Let's say 360 feet. So 60 times 1.22. So let's say the horizon would have to be somewhere, just an approximation from about 360 feet. The horizon would have to be about 15, 20 miles?
No, I don't. Well, I don't think so. But what's that got to do with it? The point is,
Because
if it's flat, if
your
it's
model,
flat,
wait, hold on, let me make a point.
no,
In
well,
your model,
yeah, Brian,
hold on. In your model, the sun is 69 miles per 1 degree. Per 1 degree now. So even if I'm seeing the horizon,
no. That's you're talking about Polaris. Polaris will appear to sink by 1 degree each time for each 69 miles.
I'm talking about Eratosthenes. It's close.
I think you're all over the place, Brian. The fact is that over a flat plane, a flat plane,
don't run from my point.
The sun,
Brian. I need to ask.
There's no point in having this debate if you won't let me speak, Brian.
Wait, can I ask my fucking question? Excuse my language. What angle could the sun possibly get from a horizon 20 miles or at a building 360 feet in the air? What's the best possible angle it could get? It couldn't even get about a quarter of a degree. So if you're talking about clouds at that height. I'll end it with this. I recommend everybody go to P-Brain if you want to see the sun on the bottom of clouds, and he shows the perspective. And perspective's a funny thing. He explains it real well. But go ahead. Sorry, man. Sorry for my language. I
don't really understand it. Well, you can see shadows of Mount Rainier being cast upwards onto the bottom of clouds. So therefore, the sunlight must be coming from lower. You can see sunlit bottoms of the clouds. It's a fact. If you, you can actually go to Burj Khalifa and do this. Stand at the bottom, watch the sunset, whiz up in a fast elevator, and watch it set again. In fact, you should be able to do it by laying down at a beach as close to sea level as you can get. And the moment last bit of the sun drops below the horizon, stand up and you'll see it drop behind the horizon.
Flat Earth model predicts that perfectly, man.
I'd like to see a flat Earth model.
I go to my channel. I have a refraction model for Polaris, the moon, the sun. It's just simple math.
Well, it's not simple, because if you had a flat plane and you had Polaris at a distance above you, starting at the North Pole, it would be 90 degrees above you. If you move 69 miles and that dropped 1 degree, if you moved another 69 miles, it cannot, just with basic trigonometry, drop 1 degree again. So if
that breaks down in the globe model, that breaks down 30 of the 180 degrees that we have, because you say, it starts to do funny things. It's non-reliable 15 degrees down. So from each horizon, that'd be 30 degrees of unreliability. Now, on my flat Earth model with upward refraction based on the humidity zone, it's 6 inches per mile squared of upward light refraction causing Polaris, and it maps out perfect. Almost perfect anyway.
So are you assuming exactly the same humidity over the entire Earth? And where did you get the 6 inches per mile? I don't know what you're talking about. I'd like to actually come to another point to move it on a bit, Brian. You mentioned in your intro 1,000 mile per hour spin of the Earth. It's not spin, it's rotation. It's not 1,000 miles per hour. It's 1 rotation per day. If you went to a fun fair, okay, if you took your kids, if you've got kids, to a fun fair and there's one of those merry-go-rounds and that's rotating at 15 degrees per hour, I don't think they'd want to go on it. It would take them a day to get round. Not scary, not exciting.
Because of the angular momentum, right?
Well, it will still be 15 degrees per hour.
Of angular momentum, right?
But what is your problem with that? When you show a little spinning ball whizzing around like that, that has massive angular momentum.
If you do the math, it's off the freaking chain, dude. The angular velocity.
With a small ball, yeah.
No, not with a small ball, but no, with the Earth, it's off the chain. You have to start using exponents.
No,
listen,
if you took a kilogram weight, went to the equator. Now you'll have to forgive me because I may have got the exact number incorrect. Okay, but it's something like that kilogram, due to the centrifugal effect of the Earth rotating, the angular momentum will make that kilogram weight be, I think it's 0.3% lighter.
Right, and let me tell you my problem with that.
That's not scary. That's not flinging you off.
Let me tell you my problem with that. Okay, if the Earth is traveling at 1,022 miles at the equator and the Earth slammed on brakes, and I've asked this question to several Globers, then if I'm at the equator, I go flying off at 1,000 miles an hour. Yeah. If I'm at the North Pole, hold on. If I'm at the North Pole, I nothing happens. If the Earth slams on brakes, I might just stumble a little bit. But you're going to tell me the difference between me flying off at 1,000 miles per hour and the difference from a little trickle, that's 1.5 times the speed of sound almost. And you're going to tell me that you're only going to get a 0.5 gram weight difference? Now, if you do the math for the angular velocity, it's off the chain, man. They like to compare being in a train or a car or airplane with a roof and all that. But here's the problem. If you're going to put me on a train and say if I jump up, then I'm going to land back down the same spot on that train or airplane. But if that train, y'all don't go past the surface. If that train is traveling in a circle, then I'm not going to land in the same place.
Well, it depends how big
y'all always neglect that. And I'd like you to address that instead of changing the subject, please.
No, I'm not changing the subject. I'll address that. Let's say you said a train. Let's do something a little easier. A car, okay, or an open pickup truck, okay? If you're going along straight and you just jump up and down that open pickup truck, you're going to land back in the pickup, on the flatbed. If it's going round a little roundabout at speed, then you're going to be flung out. Now, if instead your circuit is a circular path roughly around the edge of Texas, then you're not going to get flung sideways, are you? It depends on the size of the circle you're going in.
I think if you look into the math, man, if you look into it non-biased, you'll find some problems with that.
Well, Brian, if we're driving along at 30 miles an hour, okay, and I yank the steering wheel, okay, to turn a 90-degree bend straight away, you're going to get pushed to the side in your seat. Oh, you'll feel you're pushed to the side, aren't you? That's your momentum wants to keep you straight. It's not actually pushing you. You're just trying to carry straight up, but you feel flung outwards. Now, instead of me hanging a sharp right at 90 degrees, let's say I just nudge the steering wheel a little bit. So it takes us several miles to make that turn. You're not going to notice that you're turning. That's not a problem. That's the way it works.
No, the Earth travels so many meters a second.
Yeah.
Okay. It would be a couple miles in a few seconds, man, which would require deviation.
Okay. To turn a full circle, you've got to travel the entire circumference. But to travel a full circle in 24 hours, roughly, you're going to be traveling whatever it is, 1,000 miles around the entire circumference of the Earth.
Hey, I knew we got up on. It's not a flat Earth debate if we don't talk about Coriolis, man, before the end.
I would like to hear. Okay, I'm going to give the floor to you, Brian. Please tell me what you think Coriolis is.
I know y'all's explanation. That's just not Coriolis.
I'm asking you what you would say Coriolis is.
According to the globe, it's some fictitious shit. Okay, it's a fictitious force in either model. Actual Coriolis. Let me explain real quick what actual Coriolis is. Actual Coriolis is two reference frames, okay, and an object or something, okay, an observer, okay. If you have the non-rotating inertial reference frame, okay, and you start the non-inertial moving reference frame, say a roundabout, for example, okay, and you take a ball and you throw it up in the air, it's going to appear to curve. That is Coriolis effect, okay. Now on a globe, it's attributed to the different speeds, the 1,022 miles at the equator going down to zero, let's say at the axis of the North Pole, let's say. Okay, so there's math for that and everything else. But there's a couple problems with that. One, you're using the same reference frame. You're having to say that the atmosphere is the same reference frame as the Earth that we stand on. Am I correct?
Well, I'm not really sure that you do know what Coriolis is, Brian, with all due respect. Because let's use your concept of the equator traveling at 1,000 miles an hour, okay? And let's say that a few miles up, it's traveling at 900 miles an hour, okay? Just for a sake of argument. So if I fired a bullet northwards, it's going to travel at speed northwards. Okay, I've aimed at a target.
So it's going.
Now, hold on. Please let me finish. I'll let you speak.
You're just repeating what I said for the sake of saving time. No. I know the globe argument inside now, and I'm trying to save time. You're saying that the Earth is spinning slower toward the North Pole, so the object is a bullet's going to deviate to the right. It's just not demonstratable. Can you demonstrate? I can demonstrate actual Coriolis on a roundabout or any, you have to say Coriolis, bullet, where you have snipers arguing for both sides, and you cannot isolate whether that's wind or spin of the bullet, the Atlas effect. I mean, there's so many different effects, and it's so minute, you could never prove your point. But go ahead, sorry to interrupt.
And I'm going to put a question mark or an exclamation mark on that. Sounds good, guys. And then Mr. Sensible.
Thank you. Yeah, so if you're traveling eastwards at 1,000 miles an hour, when you fire that bullet is not only traveling north, because you fired it north, it's still traveling eastwards at 1,000 miles an hour. So in effect, it's going at a diagonal, or apparently the target you're shooting at is moving eastwards as well, but not at 1,000, at 900 only in our example. Therefore, Brian, you need to let me respond, please.
Yeah, go ahead. Sorry,
Therefore, that bullet would miss that target because it's still moving eastwards at 1,000, whereas the target's moving eastwards at 900. So it overtakes it. So yes, it would appear to the person who fired it directly at the target, it appears as though it's curled to the right. It hasn't actually curled. It's still going in a straight line. It's a deviation due to conservation of momentum because you're moving from an area at one speed to an area at another, which is something that Mr. Nathan Oakley blatantly doesn't understand because he feels that if you jumped off the ground or went up in a helicopter, the ground would whiz away from you at 1,000 miles an hour.
You don't think the rifling of the barrel,
which is not Coriolis.
So you don't think the rifling of the barrel would have a similar effect? You say if I shoot north, it's going to curve right. If I shoot south, it's going to curve right.
Yeah, because when you
don't think the rifling of the barrel, like if I spin a baseball and throw it real hard, it's going to curve. It's going to curve to the left. So the way the barrels, you can easily attribute that to the Elias effect and the spinning bullet.
Right.
But,
well, what I would say regarding guns, Brian, I have not got much experience of guns. I do know what rifling is. I don't know if sometimes you can have rifling one way and the other. That would be an interesting experiment. Maybe you can have guns that rifle either way. But what about cannon then? An old-fashioned cannonball. The same would happen with that, and you don't get rifling there.
There's records of them back in Samuel Robothan's day. They have records of firing cannonballs under plumb line straight up in the air. And the cannonball landing even back in the muzzle a couple times, but always right there, right by the cannon. There's
Samuel
a video on
Burney
YouTube of a guy firing
Samuel Burney Robotham was a snake oil.
Stays up for like 2 minutes, and they have to go and take cover because the bullet, when it comes back down like 2 minutes later, it lands like within about 30 yards of where they fired it straight up in the air. Well, okay, that's a video on YouTube. Look up a guy firing a rifle straight up in the air. The Coriolis effect is fictional.
You have conservation of momentum, Brian. Again, let's take it at the equator, moving at 1,000 miles an hour. You fire it straight up. Then that cannonball or bullet is also moving at 1,000 miles an hour, plus it's moving upwards.
So it's not deviating then. So is it conservation momentum or deviation? You can't have both, bud.
Right.
Listen, are you speaking of one reference frame or two? Is the Earth and atmosphere moving together, or are they two separate reference frames?
It's not the atmosphere that's affecting it. If you're firing directly upwards, you're moving from an area at one speed to exactly the same area. It will go straight up, straight down because of conservation of momentum. If you fire it northwards, you're moving from an area of one speed to an area of a different speed. Therefore, your conservation of momentum will affect its apparent.
If I'm on a car driving, the same thing happens. If I'm traveling in a dragster from the equator to the North Pole or something, or a rocket car, are you telling me that my right tires are going to wear out quicker or something because I'm going slow? Well, basically, that's what your math says.
No.
I understand your math and your conservation momentum, but in reality, it just doesn't fly, bud. You need to get out in the real world and look at some of the things and look at some of these videos of people getting out doing things. This Coriolis you have on paper doesn't work in reality, bud.
Only it does, Brian. If you're in that drag car, and you point a drag racer, you point it northwards. You've got an eastward motion of 1,000 miles an hour at the equator because of the rotation of the Earth. Are you saying that you would still be able to go side? You can't drive sideways. The grip on the tire would prevent it. So in effect, you're slowing down. You're cancelling that conservation of momentum. We're talking ballistic objects you can throw, objects you can fire. If they've got control surfaces, if you're adjusting steering, then that goes out the window. Of course, we're talking about objects that are just unpowered.
in a different reference frame or the same reference? Why would
You're in the same reference
what if
frame.
I had a dragster and a plane flying directly over that dragster? Okay. Are they both in the same reference frame the whole time? It's a simple question.
They are. They're in the reference frame of the rotating Earth, to my knowledge. But the point is, both of those are powered vehicles. You steer them constantly.
Okay. What if I just tied the steering wheels and put a little string and attached a plane, and left a little slack and just took them off from the equator to the North Pole, hypothetically speaking? Are they going to be in the same reference frame the whole way?
I really can't see what you're getting at with this, because
yes, you can.
No, I can't, because
this is just a thought experiment. If I have a rocket car,
okay, it's not a very good thought experiment. Or I would ask you to think on it more, Brian, because both of those vehicles are powered vehicles. The drag racer has friction; it has tires that are pressed against the road that prevent it from going sideways.
That's why I mentioned the tires getting bald on the right side.
Yeah.
But the fact of the matter is, in your model, that you're using the atmosphere and the Earth as the same reference frame. Therefore, there would be no change. In reality, there'd be no change. But that's my point, man. And my point, I would like you to specify, if you're talking about one reference frame or two, because Coriolis distinctively says there's an inertial, non-moving inertial reference frame and a moving reference frame. And that's the definition of Coriolis. It's easy to demonstrate in real life. Just go to a roundabout or go to a ride at the fair. It's very easy to demonstrate.
And what do you do at that roundabout or ride at the fair? What do you do to demonstrate it?
Just throw a ball up in the air.
Right. But
you can throw a ball across the roundabout. It's going to curve. It's going to apparently curve. That's because the ball is leaving. Listen, when you throw the ball, okay, it's leaving the non-inertial reference frame, going into the inertial, non-moving reference frame. So it's going to appear to curve. The roundabout is spinning. So when you throw the ball, it's not going to really curve in real life. It's just going to appear to curve. That's the definition.
Talking about, when you say throw it, are you talking about throwing it towards the center, throwing it up?
You throw it wherever, it's going to have different effects. But if you throw it straight across, it's going to appear to deviate opposite of the rotation. But it's not really going to. If you're in
it'll go straight. It'll go straight. Yeah.
Yeah, but it'll appear to the person spinning, it'll appear to curve.
Yes.
And there's two reference frames. That's because there's two reference frames.
No, there's one reference frame.
No, inertial, non-inertial. Look up the definition, man. Unless you have another definition.
In fact, I would say that I've seen quite a few videos about that, with them sort of trying to throw a basketball across the roundabout to each other as an example of Coriolis. I actually think it's not that brilliant an example, because it's not really describing the full effect. But Coriolis is a thing. Because the other thing, Brian, is that's why we have hurricanes and so on, rotating weather systems, which rotate one way north of the equator and the other way south of the equator.
That's
because of Coriolis.
True.
Sorry?
That's not always true. I'm in the hurricane belt.
Occasionally one can go the wrong way, but it doesn't last as long. Occasionally one can cross the equator, but it peters out a lot quicker than it would have done.
That's not necessarily true either, but yeah, it's the same thing. It's really the hurricanes here where I'm at, they come off the coast of Africa and they all go north. None of them even go south here and around the United States.
But they all rotate the same direction, don't they?
Yeah, just say if the sun is sweeping around, it's a necessity.
Are you talking about the sun basically stirring it?
The sun is the energy that's creating the heat, that's creating the hurricanes to begin with. The sun, the great agitator, that's what's creating the hurricane. That's what's creating all these pressure systems, these differentials. That's what's making the weather. So
yes,
as it passes by,
that's not an explanation for why. No, hold on. It's not an explanation for why weather systems north of the equator rotate one direction, weather systems south of the equator rotate the other direction.
They don't always do that. That's a myth. Same thing. Look,
hold on. Not 100% of the time, Brian.
At the equator, there was a scam. Hold on, there was a scam at the equator where a guy had a sink.
Yes,
you take a bucket of water, okay, and everybody says the water will drain in one side. That's a scam.
Yes,
same thing with hurricanes. They don't always follow that pattern.
You have a look at weather forecasts or weather satellite imagery and show me how many of them rotate the other way other than expected. Why is there that dividing line at the equator?
Well, if it's due to Earth curve, it would only take one. Okay, if it's spinning against Earth curve, and it's a hurricane, okay, to me that shows that it's not the Earth curve causing it.
So if 99% or whatever it is of weather systems north of the equator rotate one way, and 99% of weather systems south of the equator rotate the other way, you'd think it's just storms.
I think
there's got to be some reason it's not 50-50. Because by chance, if it was nothing to do with Coriolis, by chance, half of them would rotate one way, half of them the other.
Okay.
And the mix would be the same north and south. It's not.
If you take a plate, and next chance you get, just take a dinner plate and go to a pool, okay, and just take that plate and rake it across the water away from you. Fan the water out away from you, okay? You'll see the one off to the right spinning counterclockwise. You'll see the one to the left spinning clockwise. You'll see two shadows just cruise across the pool, even though the plate's still in your hand. It's a cool thing. You could look it up. Look at a plate across the swimming pool. It's the same thing as the sun, man. I think there's a lot of other explanations than your globe Earth. Man.
Okay. Let's take that explanation. I know exactly what you mean about sweeping a plate through. Yep, that happens, of course. So if it's the sun, when it's summer in the northern hemisphere, the sun's above the Tropic of Cancer. When it's winter, it's above the Tropic of Capricorn. It basically moves 23.5 degrees north and 23.5 degrees south of the equator.
Yeah,
the line of difference to where the storms rotate one way and the other way is always about the equator. It doesn't move northwards.
Quick point on that. And you attribute seasons. I've heard a lot of questions in chat, on previous debates about seasons. They work way better on a flat Earth. Just a quick point. I had my son, I made a quick video on flat Earth test. Anybody wants to see these? It's all caps, flat Earth test. It's about a 2-minute video. My son, we took a picture, I showed the sun off just barely over the trees on the horizon, up about 10, 15 degrees in the dead of summertime. And I tell him, put his arm on the car. The sun's just barely over the trees. I challenged him to hold his arm on the car. He put his arm on the car and he's like, woo! He couldn't hold it on there for a full second when the sun was just barely over the trees. About 30 minutes over the trees. Now, if that's the angle to the sun in the wintertime, you lay on that car with the sun as high overhead as it gets. And you're like, it feels so good. It never gets that hot compared. So if it's just the angle, then it just doesn't add up, man. The devil's in the details, man. You look past some of these superficial explanations and you see different possibilities, man, different examples, different solutions to some of these problems, man. I just think people need to open their mind up a little bit. But it's a good debate, man. I've enjoyed this. I'll leave it to you, man. I'm sure.
And we got 10 more minutes, guys. So it's been fun. Sending love to both of you before we go into our Q&A section for all of those lovely questions that you guys have been sending in. But all right, 10 more minutes. The floor,
10 more minutes.
Okay, still your guys.
Okay. Well, I haven't seen you actually address, anything really about stars. Although, to be fair, when I asked you what you wanted to debate, you said stars. I didn't really know what you wanted to cover. So I'm happy to leave that. But you did mention about local sun and that bright spot. That's called a specular reflection. If you had a shiny ball and held out in the sun, you see one little bright spot.
That's it. Hey, Mr. Sensible, that's in art and photography, the specular reflection, man. Wouldn't you think? We don't see it on the moon. What do you mean?
But there's a big difference. There's a big difference. If you had a concrete ball, from a sort of garden ornament, you wouldn't see a specular reflection.
Just use the moon as an example. Just use the moon.
No, it's the same, because what I'm saying is the difference is water is highly reflective. Concrete or rock, like the moon rock, is not highly reflective. So you're not going to get a specular reflection. Although if you have a look at the image of the moon, you will see brighter area fading, just not greatly like you do with the specular reflection in those balloon shots.
Can I make a quick point to the audience real quick? Okay. I wanted to do I had this in part of the video, man. I got caught off guard, and so I didn't get to condense my actual video. So I just showed something else. I do apologize about that. I want to make a quick point, okay? And there's an explanation for this. To me, it doesn't suffice, but everybody out there, okay, picture the sun in the center and picture the Earth. Just picture the heliocentric model. Picture the Earth. Picture you're in Ecuador, and then picture the sun during midday. So you're facing directly at the sun. Now it keeps turning. 12 hours later, you're looking directly away from the sun with a 23 degree tilt. You know, besides the tilt, you're looking directly away from the sun. And pick a. It's funny you picked Orion earlier. That's an equatorial constellation. It's seen in both the northern and southern hemispheres, and you'll see it overhead in Ecuador at a certain time of the year.
And in the extreme south, for some strange reason, it's upside down.
Let me make my point. Okay, yeah.
I've made mine.
Okay, now, yeah. In fact, okay, so now, midnight, we're looking directly away from the sun. Now, 6 months later, we're on the other side of the sun. Okay, it should be a whole nother set of stars. Okay, now I got a video on
Brian.
Hold on, let me make my point.
Well, hold on, you're supposed to be debating me.
I got a video on my channel showing Orion over 9 months.
Right, and Brian, what I say is you're supposed to be debating me, and yes, this argument about seeing different stars doesn't really hold, because you just need to 3D.
You mentioned the stars, man. Why would you interrupt me right at the damn end of my point? Okay, let me say the end of my point. Point is, okay, is that 6 months later, you are looking opposite the sun. So if you picture a ball in a room, okay, being the sun and another ball being the earth, look at the wall pointing away from the sun is the midnight sky. 6 months later, it's the other wall on the other side of the room.
Yeah,
now, how am I seeing parts of Orion over 9 months of the year if I'm looking into a whole opposite end of the universe? Okay? All they'll say is the universe is big.
It depends on angles and so on. Here in the UK, we see Orion through the winter and sort of part of the spring, part of the autumn. In the summer, we don't. It's still there. It's just up in the daytime. But we're rotated and pointed in the wrong direction.
Speaking of daytime, another problem with the heliocentric. Two more problems. Okay. One, okay, we could see Venus and even seeing Mercury at twilight is a problem.
Yep.
Okay?
No, it isn't.
Venus
three-dimensional angles and distances.
Venus, if we're the third planet from the sun, okay, and Venus is 1/3 closer to the sun than we are, okay, then how could we see it at night at all? How would we see it ever at night? We'd have to be looking toward the sun to have the angle to see Venus.
You're not here for a diatribe. You're here to raise a point and me answer it, or me raise a point and you answer it. Yeah, you can see Venus and Mercury. Mercury you only see for a short distance after and before sunrise, sunset, and Venus a little longer. You just need to work out the angles. It's perfectly possible. It's not a globe killer.
It's a globe killer if you set it up in reality. If you scale it in reality with a globe like I got right here, okay? You take this globe and scale the sun and scale your little Venus and get your string line.
You better put the sun over it. You better put the sun over in Washington.
Will you please quit cutting me off, please?
All right, guys. Brian, we'll let you finish your statement, and then we'll send it back and forth.
Okay. If you set up a string line and scale the sun, you don't have to scale the size of the sun exactly, but we'll go by the center of the sun. And scale it as close as you can and set up a string line. You're smiling, but try it. It does not work, okay? And one other problem on the heliocentric model, NASA calls the impossible eclipse, when you have the sun and the moon above the horizon at the same time, okay? And they say the Earth is causing the shadow during that lunar eclipse. But we're looking at the moon over the horizon and the sun over the horizon. And if that ain't the killer, when the shadow does come in, it comes from the top down. So if it is the Earth making that shadow, then it couldn't be the Earth making that shadow. It would come from the bottom up as the moon set. It's not even possible. That's why NASA calls it the impossible eclipse. Go ahead, Mr. Simpson.
Okay, the Selenium Eclipse. When the sun or moon or other objects are near the horizon, they are refracted up slightly. I think it's by about 5 degrees. So when you see the sun just about to touch that horizon, it's already gone beyond it in reality, geometrically. That's just what you're seeing optically. So in fact, they are not both physically above the horizon. They just both appear to be above the horizon. A Selenium eclipse is not an impossibility. And if you want, you can use, I forget the name of the software, these software where you can set up models of the solar system and so on, positions and dates and times, whatever, and you'll see that it does all work.
So where's the shadow? Like if I'm measuring the shadow to the sun in my front yard, I'm still getting the shadow. Hold on. My solar panel. You're just naturally jumping every time I go to speak. I'll be in just a second. Okay, now my solar panel. I'm checking the charge to my solar panels, and that sun that ain't there is still charging my solar panels. I'm still feeling the heat and getting a suntan from it, but the moon is not. I understand that you have to have an explanation to keep your model. So you say that the sun's not really there, so the shadow's refracting. But let's be real. Let's try this in real life. You can't, if the sun is actually there and it's shining on my face and the moon is above my face, the moon should be getting the same charge that my solar panels are getting, the same suntan my face is getting. It doesn't make sense. And then for the shadow to come from the top, you know, even if I give you the refraction, the shadow then comes down from the top down. It's a model killer, man, in my opinion. But over to you.
Well, if you can see the sun because it's been refracted above the horizon, then the rays of light from the sun are going to hit your face. As simple as that. And whether the sun is above or below our horizon makes no odds to the moon, which is 250,000 miles away. Exactly half of the moon is lit, half of the moon is in shadow, and the same for the Earth at all times.
Yeah, but
so if you take a globe and shine a torch on it from one side, 50% approximately of that globe will be lit. You have a look at the flat Earth map, whichever one you care to take, and the patterns of daylight and nighttime do not work. They simply do not work.
Sure they do. Sure they do. You haven't researched enough, man.
No, I haven't. Believe me.
Maybe we can have a part 2 and focus on the refraction.
That is a fantastic idea. We should definitely have a part 2. In fact, with that, we are going to be moving into our Q&A section. So this is your chance to send in questions to either or both of our interlocutors, Mr. Sensible and Brian. Also, super chats are turned on, and they will move your question to the front of the line. So remember, folks, don't forget to like and subscribe. And with that, let's get to some more fun. So a $2 super chat from GPS. Both sides. How does GPS work?
Well, I'd be interested in Brian answering that first if he hasn't gone.
How does GPS? No, I'm not gone. Triangulation. It's triangulation. It's a ground positioning system. I don't think it'd work too good on a ball. GPS uses Cartesian coordinates, which you could mathematically convert to a ball. But I think GPS has its own problems. They have to make adjustments twice a day to the satellites. If they just used, on a flat Earth, I don't think they would have to. That's my opinion. I have to look further into that. But, you can't use a model to prove a model. So any questions, y'all, if you haven't put your question in yet, don't try to use your model to prove your model.
Oh, interesting. Well, GPS couldn't possibly work in the middle of the Pacific Ocean or middle of Antarctica if it was ground-based. It's from satellites. You get time signals from several satellites, and then allowing for Doppler shift, you can calculate how long they took to get to you and therefore your position. And an interesting fact I came across the other day, the atomic clocks in GPS satellites actually run slower deliberately. They're made to run slower than atomic clocks on Earth, because when they're up there traveling at speed, they speed up, and we need to keep them in sync, which was a fascinating fact.
Maybe that's why we have to. Maybe that's why we have to adjust the satellites twice a day, is for the time dilation, because they say that the Earth is moving around the sun, so they have to do their adjustments. So naturally, it would have to be time dilation would have to be a thing if we're moving around the sun and are not measuring it. Basically, if we can't optically see that. But it's no wonder they have to make adjustments, man. In my opinion, the GPS. One quick thing, everybody, check out Brandon's. We talked about time dilation for days at a time. We've never got anything significant for an explanation on that.
Longer. It seemed a lot longer, Brian.
Yeah, go ahead, man. Go ahead.
Perhaps we go to the next one.
$5 super chat from Sally. Oh, wow. Mr. Sensible, been a sub since the beginning. Love him. Got a fan out there.
Nice one. Thank you.
Boo!
$2 super chat from Dora. Uh-oh. €1 per brain cell of Ryan. Uh-oh, spicy.
Gee, thanks. I appreciate that. You really had to spend money just to be a jerk.
$2 super chat from Hake. He is proudly pointing to himself as a baltard. Thank you so much, Hake. Running right along, and we will eventually go into regular chats, but remember, if you want your question moved right to the front of the line, super chats are the way to go. $10 from Rad Crab. You guys are both boneheads. Gravity is a lie made up by big astrology. Everybody knows that we are tethered down to the earth by the noodly appendage of the flying spaghetti monster. Beat that, flatheads.
Yeah. Yeah, all blessings to his noodly appendage, I must admit. Yeah. And there's a distinct lack of pirates, and climate is getting warmer. It's got to be the cause.
Hey, to that comment, come to Brandon's. It starts at after this show. Brandon's BRAND''S. He has a show, and everybody's free to join. And come tell us about the spaghetti monster globe. I'm very interested to hear.
Ooh, and that's right. We host all after shows on this channel. Just send in love. And all right, $2 super chat from Mike Minazzi. I am now a flat earther thanks to Mr. Sensible. Uh-oh.
Ooh. I'd love to know why.
And all right, we're going to move into some chat questions. Feel free, keep on tagging me at Amy Newman. That helps me separate and spot them. Could you ask Brian why the sun does appear to move at a constant velocity? If it was local, perspective dictates that as it gets further from the observer, it would appear to move slower.
Man, I think a little bit of refraction once you get past about 50 degrees fixes that. I have a model that fixes it pretty sufficiently. Check it out on Flat Earth Test on my channel, and then see what you think.
Amazing how the refraction always keeps it exactly the same size, though, isn't it?
It's just, magnification does that. That's been demonstrated, and to be honest, I probably might get a lot of insults if I keep acting like I know exactly what the sun is. Dr. Pierre Robotot just won the award. And then now he's using that same technology that he just invented, the latest MRI machine, and applying it to the sun in spectroscopy. And he has proven that the sun cannot be a gas. They need to update the model. It's not a continuous spectrum. It can't possibly be a gas. All the gas combined wouldn't show a continuous spectrum. So there's a lot of work to be done, man, in cosmology. I think everybody knows that.
Only the spectrographs of the sun, as I showed spectrographs earlier on, demonstrate exactly what the sun is made of.
It's not isolated, though, man. The way they use spectroscopy in the lab and isolate it with where they know exactly what's in between. There's no way of proving what's exactly between the sun. Like I said, it's still the sun is full continuous spectrum, and spectroscopy doesn't show that. So,
just out of interest, Brian, just out of interest, do you know what color the sun is?
I would say it's white, being that it's continuous spectrum, Mr. Sensible.
Well, it is white, indeed. It is white, indeed. I just wondered if you knew.
Yeah, it's the full spectrum. Is Amy muted?
Oh, had myself double muted. I have to do that at least once a stream. The spice continues. Ask for Brian, when's the flat earth side of the debate going to start?
I mean, I think I gave enough reasonable doubt then. I brought up some topics, the possible eclipse. To me, just look up at high altitude, man. I guess, man, we must be seeing things with different eyes, man. I understand the heliocentric model. It's the best model out right now, but the flat Earth is it's gaining ground, man. There's more and more explanations, more and more models coming out. Check out Steve Torrance if you want to see the model of all the planets, the sun, for like 20 years in the future, and it's terabytes of information. Steve Torrance, Torrence, to check out some pretty good flat Earth models, man.
And the problem with these flat Earth ideas and flat Earth explanations, Brian, is that none of them will gel with any of the others. They're all contradictory. That's a problem for you.
Like the sun not really being there, right? Like heliocentric models got some far-fetched ideas, but still some explanations nonetheless. So there are explanations. You just got to open your mind and look into it, non-biased.
Well, having an open mind is good, but you don't want it so open that it drops out your head.
I'll remember that.
$5 super chat from Angel Gamer. Mr. Sensible, I don't know much about stars, but I know I love fluffy little kittens.
Quite right, too. Excellent. I'm glad you brought that up, definitely. I had one here earlier, but he's cleared off. Mr. Arnold was here. I was hoping to show him on stream, but he's gone for a walk. But thank you very much. A worthy super chat, that.
Woohoo!
I agree.
Ladies and gentlemen, we can finally come together and agree that kittens are adorable. But yes, $5 from Truth Nerds. GPS is based on multiple adoration and not triangulation, i.e. distances, not angles.
Yeah, he's right. I said that wrong. I meant to say trilateralization. That was my mistake. He's right.
And his last bit was receiver specs are public documents and open implementations exist.
Right. It all depends, okay? Is the satellite curving over top of us, or is it going straight overhead? That's the question, okay? You could model it as the satellite going straight overhead, or you could model it as it curving over us, okay? The question is, we're waiting to see proof of the curve, and GPS ain't proof of the curve, okay?
They orbit around the Earth, Brian.
Or they circle.
Oh, dear.
I was going to say.
Curve started to show the 700-mile track of them little satellites. What are that little string of satellites called again, Mr. Sensible?
Starlink.
Yeah, Starlink. I caught them at a video of a good angle side to side, and they're going straight as an arrow overhead. A 700-mile span of them, and if you're looking off to the right, it should project. It should exaggerate Earth curve. If you look to the beginning of that trail and the end of that trail, further away, it should be down lower. Plus the curve of the Earth, we should see some big time curvature, but we don't see that. We see a dead straight line.
Yeah, well, it's certainly going to visually look straight due to the size of the circle. The orbit, I mean, the size of the orbit. So it's going to look straight by eye.
So it looks straight. It's curving, but it looks straight. That's the story of the globe. Everything looks flat, but is actually curving.
Well, the thing is, Brian, you're right. Your eyes as instruments to detect things are actually pretty crap. And slight curvature. I mean, we're not talking about looking down a length of 4x2 to check to see if there's a slight bend in that piece of wood. We're talking about something that's hundreds and hundreds, thousands of miles long. And if the curve is just a couple of degrees, you are not going to see it. You need sensitive equipment to detect that.
Yeah, well, that's why Einstein said there's no optical experiment that could prove the curvature of the Earth. But let me say this: in your model, bending light, refraction makes the Earth look flat. Okay, ain't that counterintuitive a little bit? So if we bend the light, we make the ground look flat. I mean, that's just counterintuitive. A lot of things about the globe are counterintuitive, man.
I'm not quite sure what you're quoting there.
I'm just pointing out, what's like the black swan. Not trying to go off in a tangent about the black swan argument, but in your model, the curved light, the refracted light or bent light, whatever you want to call it, changes in angles, are making the Earth. So in your model, basically, the curving, bending light are making the ground and the Earth look flat. That's counterintuitive. The bending light should make things look bent. That's what I mean.
And I appreciate you not wanting to go off onto that black swan, but with that, there is still a horizon. It's just that the refraction has lifted the sea that's beyond the horizon we would expect. So that is in view. Okay, but yes, let's keep off the black swan, which is a. I
hadn't had to resort to the black swan, man. Do not make me black swan you, man.
Good, because that picture has so much distortion in it. I mean,
but he did that on purpose. If you look at that whole video and the video the guy came out with a few days later, plus several other black swans, Quantum Eraser is no jackass. He picked that for a reason, so y'all would claim refraction because that debunks the geometry, and a lot of Globers don't understand that. As soon as you invoke refraction, you are counting out geometry, and that is why he used that exact picture.
Well, as soon as Quantum Eraser invoked Alice and Bob, he showed, quite frankly, that he's not to be listened to at all because he's an idiot.
Alice and Bob. I explained Alice and Bob. You have them going off in a void when left to right.
I'm advising you to keep away from that, Brian. You won't live it down.
All right. I'm just saying it's you only give half of that argument. The point is left to right, Alice and Bob would go up and shake hands and not do anything. Straight ahead, you would call it curvature. We would call it obstruction. And half the time we can zoom back in and pick Alice and Bob back up straight in the distance, depending on the refraction of the day. In our model, what causes obstruction is light bending. In your model, what causes horizon and obstruction is Earth curve and light bending.
Well, the problem is with his, if you've got Alice here and Bob there, they're both looking down curves. That's basically what he's described. Whereas in actuality, you've got Alice and Bob here. They both see a curve, but there's no problem. They'll walk together and meet each other.
We understand that.
The fact that Quantum Eraser actually had the lack of understanding that he posted that as an argument against the globe Earth shows he's just a chuffle.
Where you're coming from. I understand what you're saying, but like I said, you're not thinking of it in terms of a flat Earth. You're thinking of it in terms of a curved Earth where horizontal is not horizontal, where the horizon is not horizontal. You're thinking in your imagination. You're not looking out in reality, seeing what we see. I do understand you did send a balloon up, 120 miles to see a peep of curvature and all that, but that's just a circle of sight. What we see in reality is a flat horizon. What we see up in airplanes is just flat land off. And in your model, the curve, where's the curvature? It's just a little bit further. It's always just a little bit further. The Earth is so big.
Brian, you can see the curvature on the beach, okay, as well as the curvature going away from you with ships going over. You can see the curvature side by side, not with the naked eye because it's so slight. You get a straight edge, line it up.
I was about to challenge you the same thing.
Just above. Just below that horizon, take a photograph, squish it sideways. You will see your straight edge is still straight, but the horizon, if you let me finish, is curved.
Okay, take you a 2x4 in real life, not in a photograph. In real life, take you a 10-foot 2x4 and set it parallel, set it horizontal, and look down the whole thing. In real life, there's no curvature. Maybe through a camera, okay, maybe in our imaginations. In real life, there is no deviation from the horizon and that straight 2x4. I've done it.
Well, I'd like to see the picture, but I guess you haven't got it now. But I think Amy's ready for another message, I think.
Hey, I've been enjoying the back and forth, but M2M, $5 super chat. When is Mr. Sensible getting a haircut?
Yeah.
Just kidding.
I know.
Well done.
It's almost out of control now. I'm sorry.
But hey, got a fan out there. And all right. Keep on sending those super chats in. They will send you right to the front. $2.99 from John Smith. When is Hovind coming back on? I miss him. That's right, baby. We gotta get more Ken
Ken's
Hovind
fun to watch,
debates.
man. Ken's fun to watch.
Fun to watch. I know. Hey.
He's half woke, man. He's half woke.
That's one word for it.
Hey, Mr. Sensible, let me make back to that last point. You got to go look at some of these things with your own eyes instead of looking at some of these photographs. Just take a 2x4 out there to the beach or to a flat ground, and try it. You'll see it.
Yeah, well, a wooden 2x4 would not be accurate enough. You need something you need something like a metal level, but it's been done. That's a well-known image. And then if you squish it sideways, you can see that the level is still dead straight, but the horizon has a curve. So it can't be down to the squishing. Otherwise, the level would have curved as well if it was down to the lens or something.
Would you agree with me that, man, it would be cool and kind of, to me, necessary, man? We need to do another, maybe you might beat me to it depending on your resources, but it would be interesting and a lot more telling. There would still be debates either way, but if we sent the balloons up, some of these high altitude balloons with some theodolite apps, I think it would open up a whole new line of debate and on refraction and things like that.
Well, I think it would be interesting to send up something with some form of equipment to try and test that drop or demonstrate that drop. But I think those theodolite apps, I've not got one, so I don't really know. But I would think that they're quite inaccurate, really, a bit of a gimmick. You'd need something a lot more accurate. But as a general principle, sending up a balloon with some mechanism of knowing when it was exactly level and then seeing where the horizon is, yes, that would be interesting. I'll grant you that, it would.
$5 question from Shetty Bear. For both debaters, what grade did you get in your trigonometry and physics class in school?
No, I mean, I've brushed up on my trig. I use it a little bit at work. I use more geometry than trig. I own a small concrete business in Florida. I've done seawall, not real big projects, but I've done worked on bridges, mainly the skirting, but I've done a seawall like not quite a mile long. Earth curve is never in the blueprint. And even what they say as far as elevation, we go off of auto levels, man, and lasers. So whatever benchmark they give us in reality, we go off that, and we keep a horizontal line going. And the globe model, as far as calculus, man, you probably lose me in calculus or anything past that. But basic math, I enjoy. I use it at work.
And physics, I think, was the last one.
Physics, to be honest, I've learned a lot debating. I've learned from Jose J.G. Gonzalez channel, Brandon's channel, which I've mentioned a couple times, which his show starts not long after this one ends. And I learned a lot from Globers. I agree with most of it. I don't think there's any problem with the math. It's just explanations I have problems with. I'll elaborate on that in a minute.
And I would have to say that I'm no mathematician, and I freely admit it. I've mentioned that several times because I left education at quite a young age and started work, and I have not really used anything mathematical throughout my working life. Nothing more than sort of ordinary basic stuff. So I know where to draw the line and say, hey, I don't understand that. I have a layman's understanding of things. I can grasp concepts, but the actual maths can very quickly get beyond me. And I'm not trying to hide that. Definitely.
I'll grant you that. Most of the machine heads lack in other departments. I gotta admit, a lot of common sense people, are not real into math. Math doesn't prove things; it describes. If you want to say it proved things, I could use my refraction model and say, "Yep, I proved a flat Earth. Look at my refraction model." Just because the math matches and it doesn't work for other elevations either. I had to put Polaris at a certain height, or it just didn't work. That doesn't prove a flat Earth. It's just a model, like the globe model. You know, it's
but the thing about Polaris and the rate it drops actually through basic trig will destroy flat Earth because it physically cannot work. Because if you're traveling a steady 69 miles, checking the angle, 69 miles, checking the angle, it will not be dropping at 1 degree per trip. It just
like I said, but if you use basic trig, you're going to destroy both models because, you know, when you get down to 15 degrees, it breaks down. You're going to say refraction, okay? You're going to say light bending. I'm going to say fine. You know, that's your explanation. But the trig doesn't work throughout on either model. You know, you can't allow the globe model to have explanations and refraction and deny that to the flat Earth model. Okay, you say the ground's curving. I say light's curving off in the distance. I say it's due to a humidity gradient, which is measurable, calculatable. That's what my model's based on, a humidity gradient.
Well, you would need to know the temperature and the humidity gradients because they vary all over the Earth, and at any point they vary day to day.
Well, you showed earlier that temperature has little to do with pressure. Look at the gradient.
Yes.
Hold on. Look at the gradient in the Earth's atmosphere. You showed where it got colder and hotter, but the pressure just kept going down, didn't it? So temperature is one of the least effective reasons in refraction. They say it's density first, and then temperature. Okay, so the density of water vapor is less dense. Okay, where is water vapor the most at? Right above the water in the ground, and you know, even the asphalt, and it gradiates away as the water gradiates, and it ends at a certain height, probably about 50, 60,000 feet, where there's virtually no humidity left. So that's what the model is based on, is a humidity gradient and the light refracting away from the less dense humidity.
I'll just leave it. Let's leave it at that then.
$2 super chat from Bubblegum Gun. Everyone look up the optical illusion. It says Parentheon, but it may be the Pantheon. Either one. I'll spell it Parthenon. So everyone
Parthenon.
Parthenon. There you go.
But I don't know about the optical illusion.
When I think of Parthenon, I think of Thunderdome.
The Thunderdome. But thank you so much, Bubblegum Gun. And then $5 super chat from Mute Decibel. Brian, technology problems. Is your phone based on flat Earth or heliocentric technology? ? Demonstrate it.
That's another fallacious statement. I mean, technology is based on semiconductors, right? It's based on computer. Technology is not science, man. Natural science is not engineering. It's not technology. Okay, natural science is experiment. And technology, you know, there's some experimentation that goes into technology, okay? But it doesn't prove, you know, my phone, I'm going to have a phone no matter what the damn shape, whether it's infinite plane. Nobody knows exactly what the Earth is, people. Nobody knows exactly. You see, if you go into the classified document for the Army and the Department of Defense, Russia, all them, they don't know exactly what it is. They, you know, if you want to believe you do, that's fine. But classified documents say otherwise. If you look deep.
Well, I would say with your phone, it's I assume it's a fairly modern phone, so it's got a GPS chip in it, which is receiving signals from GPS satellites, which are in orbit. And so as they're in orbit, that relies on gravity. Your phone also has what I think is called MEMS chips that detect the gravitational direction. So when you turn that screen one way to the other, the screen flipped from portrait to landscape.
Ain't that funny? Yet they do not detect Earth curve. I've seen multiple videos.
How would it detect Earth curve?
People going MEMS. The MEMS technology does not detect Y or Z axis movement. Okay, look it up, Mr. Sensible. They have an excuse for it.
Yeah, but if you wanted to, the sensor in there is to detect if you're holding a phone vertical or horizontal. If you wanted to hover in 3 planes, you can just put another chip, so you're detecting rotation in the other direction. And talking of rotation, you really should listen carefully to what Bob Nadell originally said, because he detected a drift of 15 degrees per hour.
Right,
Thanks,
side
Bob.
to side. Okay, why? Okay, what was he on the North Pole? Why is he getting?
Well, I don't know what he was smoking.
Why is he getting a 15-degree-hour rotation on the XY axis? What is he at the North Pole? When we see the sun, when we see the sun setting, that's us falling over backwards in your model. Okay.
Well,
now gyroscopes
gyroscopes
don't rotate on the z-axis. Okay, look it up, man. This is something.
I would never let you design an aircraft, because the gyroscope's got to know. The gyroscope's got to know every axis that it's rotating about. Otherwise, your plane is going to crash.
Yeah, the artificial horizon stays right there, parallel. They did before pendulous vanes, and they do with pendulous vanes. Gyroscopes do not show z-axis rotation. You cannot detect Earth curvature with gyroscopes. Okay, you can say you detect the rotation, but that's arguable. That's very arguable, because there's other explanations.
Well, perhaps you ought to purchase Bob's ring laser gyroscope. I'm sure he could be he'd be happy to sell it to you to try and recoup some of the money after he embarrassed himself with that. And then you can show us how the ring laser gyroscope doesn't work.
Well, we finally got him to put out his information, and it showed at altitude. Okay, at altitude a mile higher, and at the same latitude in two different cities. Okay, it showed the 1 degree deviation in curvature due to altitude, which is exactly what the flat Earth predicts. Okay, we predict the higher you go, the faster things will be rotating. Okay, and that's exactly what his device showed. You need to go check. Yeah, the faster
the
medium around us, the heavens rotating around us. That's exactly, yeah.
Oh, his heavenly energies.
When he went up a mile in altitude at both locations at the same latitude, it showed a little over 16-degree rotation. That does not jive with a globe.
Well, no, because it would mean over a period of roughly 24 hours a day, that mountain peak or whatever it is he's on would have travelled further around around the Earth. It would be moving. That's not going to happen. It's always going to be 15 degrees per hour. But to be fair, I don't know exactly what it is you're talking about that he did. So,
hey, that'll be part of round 2, Mr. Sensible.
That's right, baby. Round 2. But right now, we got a $5 super chat from Earth is Life. Brian, have you figured out how to make spherical triangles yet?
No, I was just making a point in my video. I knew they'd pour on the ridicule that depending on the way you do the triangles with the longitude and latitudes, you take the prime meridian, okay? Long story short, they say if you go 10,000 miles and do a 90-degree turn, then you go 10,000 miles and do another 90-degree turn, and that you wind up back where you started instead of having to do a square. But I was showing if you're using longitudes and you just say use the prime meridian and turn 90 degrees off that, you're going to veer off on a degree of latitude, one at the top. So I drew a marker on the prime meridian and drew a line 90 degrees at like the top of above the Tropic of Cancer and below the Tropic of Capricorn, and they never join. They just go in a circle. They don't make a triangle. I was just making a point that nobody's going to go 10,000 miles to prove that 3 90-degree turns are going to get you in the same place. You can do it mathematically, you can model it, but nobody's going to prove that in reality.
And we're going back to regular questions, but if you want yours set right to the top of the line, super chats are activated. But question, or more of a comment, ask Brian for a model.
Go to Flat Earth Test. Look at my screen, all caps. It's kind of hard to find. But I mean, I found it the last couple times. Since I've complained about it, it's been there to find. Look, like I'd say about 10th video down, it's in the title for modeling for Flat Earth refraction model. I got the chart. There's other ones besides mine, but
Brian, you're on here now. You could give them just a rough idea. For instance, do you believe in an ice wall? Do you think there's a container over the Earth?
I used to not until all the evidence started coming in. You know, it's just so many miles and miles and miles and miles of ice walls. You know, at first I thought it was glaciers, and I thought that Antarctica would be a shoreline. But no matter what way you go, in reality, I think you're going to wind up hitting ice one way or another. I never believed in the ice wall around us, but I did believe in the shoreline. But after seeing it, there's just endless miles of examples of ice wall.
There are places with beaches down to the sea, and we can sail all the way around Antarctica. Antarctica is mapped.
Yeah, Captain Cook did it and tracked 50 to 60,000 miles.
Well, he didn't go directly round, did he? He wiggled all over the place. But every year they do. Is it the Vendée race or something? And they
the Vendée race only drops down under 60 degrees in one place, so that's misleading. Also,
but they're still going round it. They're still going round it.
They could put this whole thing to bed, though, man. The Quantum airline, they were said to do the north-south circumnavigation. If you look, they went down Africa and back up South America. And our whole argument is take a longitude or close to it within about 20 degrees and go from like Eastern Australia to Western South America, you know, somewhere in that range. And it should be doable. Or as soon, if they can't do it now, as soon as they could do that, that will put it to bed. But
it has been done.
No, it hasn't. Like I said,
you need to look at one more
quantum
orbit.
Yeah, Qantas. Right. I've looked into it. We've mapped it, modeled it on a globe and a flat Earth. It goes down to the South Pole at dog legs. The pilot admits that it's a dog leg at the North and the South Pole. Strangely enough, they dog leg at the North Pole too. I'm sure they have a reason for it, but it's still it's not a true. Listen, if they do that, I'm out of this debate. But they haven't done it to satisfaction yet. I think because they can't. But maybe they can. Maybe they will do it when they get a little bit better planes or something. But they haven't done it even close to a degree of longitude, much less a dog leg. Listen, real quick, the world record holder before that, they gave the world record to him. He went down South America. He reached the South Pole and turned around due to bad weather. That's like, and they gave him the record, but Qantas broke that record recently. But that's like swimming halfway across a lake, getting tired and turning around and swimming back. What are you talking about? The weather got bad. You're supposed to be flying above the weather. It's like negative 30, 40 degrees up there any damn way. Don't tell me that it's too cold to fly. You know, they could have flew up above the weather, man. To me,
yeah, but there's also other considerations like the distance to airports and things like that. But Brian, if you doubt all this about Antarctica, why don't you go there? You could see the 24-hour sun.
Yeah, I'd like to see that one too. Still waiting on that.
Why don't you go there? Why don't you go there?
All the 24-hour suns, go to Google. We've debunked every one of them, man. Why would they have to fake it? See, even if they've got a new one that's real, why have they put out all these fake ones that are easy to pick apart? Why would they have to do that? Why did Admiral Byrd say there was 9 months of darkness? Possibly because the further you get away from the sun on the plane out there, that it gets darker for longer and longer. Just a thought.
Brian, you complimented me on Mage, which I appreciate. Why don't you do that to go to Antarctica at the right time of the year when there is supposed to be 24-hour sun, set up a camera and prove that it isn't? You could do that. Get the other flat earthers together, get them to raise funds and do it.
It's already been done.
Well, then what are you worried about?
Go to Nathan Oakley, man. He's got a video on a guy not too fresh back from Antarctica who was there for, I forgot how long, I think 18 months or so, a plumber. So there's no 24-hour. There's I think some people argue, a couple of flat earthers have argued that there's parts of the year that you get 24 hours of light, but you never see the sun for 24 hours, which is a globe killer in my opinion. Maybe, maybe
even 24 hours of light would be impossible on a flat Earth, because on a flat Earth, at some point of the day, that sun is on the other side of the Earth, and yet part of that Earth has night, so you could not have even light at the same place 24 hours a day if it was a flat Earth and Antarctica was surrounding it.
I could then argue, that flight at the beginning from JFK to Moscow would be impossible on a globe, because when you're leaving JFK at sunset, the sun's supposed to be setting back behind California across the United States toward my butt. Okay. Now, why is the sun stay to the left? How does it catch up so quick from JFK to Moscow, man? I could. That's a globe killer in itself, in my opinion. They might have an explanation, but I don't know.
Moving right to the front of the line, $2 super chat from Mute Decibel. Brian, are celestial globes fake? Explain why.
That's a good question, man. Is the universe a globe? How big is the universe? We should appreciate the mystery in the heavens the way God intended. I'm not trying to get all religious, but the fact of the matter is, you could claim you think a star is a sun quintillions of miles away and all this, and that they get bigger and brighter and all this. The fact of the matter is we really don't know for sure. I think it's possible when they say the universe is off by Michikaku said, that their astronomy's off 10 to the 120th power, 10 with 120 zeros. That could be the size of it, I think we could do some new modeling. There's several different models, geocentric. The universe, to me, is over our head. We're in the basement. The Earth is it could be dome. That could explain a 24-hour Antarctic sun with the coffee cup caustic light coming off the dome. Something to me, in my opinion, is keeping in the pressure. In my opinion, I could go on and on for days about the heavens, man. But truth is, I don't think nobody knows for sure. They have good models.
Oh no, go if you want to.
Sorry, I was going to say, only Brian, we do know that they're real things. They're not just lights. I showed you images of the Crab Nebula, which is at the location that the Chinese, Japanese, and Islamic world astronomers had witnessed the nova. We can run spectrographs against stars. We can see the redshift. I showed you the Hubble deep space, deep field view image showing those distant galaxies. Now, because I'm not a religious person, but we're not going into that. But if there was a God who could create all that, okay, but limits us to a little disc with a dome over it, that's an awful waste of space.
Bro, you're giving too much credit to spectroscopy. I could fool spectroscopy with grow lights, bro. You're acting like, look, we don't know what's between us and the stars for sure. It's not laboratory specific, man. It's not that precise, man. It's model. It's a model. I ain't saying the stars ain't there. I'm looking at them, but according to Neil Armstrong, Buzz Aldrin, and Chris Collins, okay, Chris Collins was in the lunar rover the whole time. He said he didn't see any stars the whole time. He was orbiting around the moon. He never stepped on the surface. Buzz Aldrin,
Mike Collins.
Neil
Mike
Armstrong
Collins.
never seen any stars. The stars disappeared. It's a wonder they're not in any pictures except for that one high altitude balloon footage that only goes up about 70,000 feet. They disappear. When you get to about 100, 200,000 feet, you don't see stars. At least trust your priest.
Brian, if I was stood in front of a window with the sun streaming in behind me and you took a photograph, you wouldn't make anything out. All you would see is a shadow of me. When they're on the moon, they're using cameras in an environment that's basically black up there with very faint lights under the full sun, which is brightly reflecting off the ground in front of them. It's just simply just to do with light levels and that. You're not going to see very faint objects like stars. If you went out with your iPhone or whatever phone you got, because other phones are available, if you went out with your iPhone into the streets in the city, took a photo of the sky, you're not going to see the stars because the surrounding is too light.
And so, Brian, you're going to say
Chris Collins, though. Sorry, go ahead, Amy.
Oh no, I'm going to interrupt you. It's your, it was your question, so I'm actually going to let you do the last thought on it. But then I actually think I have a question for you afterwards, Mr. Sensible.
Okay.
That's why I brought up Collins. Okay, I'm not sure if it's Chris Collins. I'm sorry if I got that wrong. But Michael Collins. Yeah, thank you for correcting. Yeah, that's why I brought him up, because he didn't remember seeing any stars from Sicily, the area between the Earth and the Moon, that's always in the sun, I guess. Maybe not always, but that's why I brought up Collins, because he didn't remember seeing any. And that would have been a memory of his lifetime, but he didn't see any stars. That has nothing to do with photography. That's human eyes saying that. So that's my argument. I understand there's an explanation, man, but devil's in the details, man. You look deep enough, you find problems.
And okay. question from the Dark Cloud. Why do so many organizations use a flat Earth as their flag, like the United Nations, for example?
Sorry, is that to me?
I interpret that as being that for you, but I'm not actually 100% sure.
Okay, well, I guess we can both answer. It's simply a nice icon. It's a simple icon. A globe, drawing a globe will not be as clear and as impactful, I think, as a logo as that flat Earth. It's just an image. It doesn't say that that's what reality is like. I don't know if you've got any thoughts on that.
That's how they, you don't use globe to travel the chart. They didn't use globe. They used maps, flat maps. But if you're going to use longitude, you're using converging lines. So if you're going to map something and you start with Polaris, okay, you're going to have circles coming out, going further and further, our latitudes, right? And if you converge them all to Polaris, okay, I recommend, to make a long story short, I recommend everybody go to Decimal Z channel, Decimal Z, capital Z, and he mapped out a spherical tabletop mathematically. It's just a model, okay? And he could use the math to prove that tabletop was a sphere by using the math. Use strings, but it doesn't prove the tabletop was a sphere, okay? It's just AE mapped as azimuthal equidistant. So once you get past the equator, every ring below it is equal distance to the latitude above it. It's called AE map. It's azimuthal equidistant. Okay, they reflect off of each other, and if we could get down and if we had a lot of money, we could go down and find out for sure. But you've got to get to the edge. But we got to be able to see the whole thing to find out for sure. In my opinion,
all the maps you use to find your way around, they're flat pieces of paper, yes, but they're projections of a globe. If you actually carried a globe around, you wouldn't have anywhere near enough fine detail. If you get a fairly large globe, have a look at it, your country. A city on that globe is just a little dot. Smaller cities won't even appear. You actually want to find your way across the states or whatever, you're going to need a map or maps, or nowadays, a nice GPS system based on satellites.
Yeah, based on Cartesian coordinates.
$5 super chat. Oh, he's coming after you, Brian. So do you accept celestial globes as valid representations of reality, just not what the objects are?
Okay, is that the same guy? Is that the same guy?
This is from Mute Decibel, the same guy who asked, are celestial globes fake?
I'll try and be more concise. No, I think it's more of a celestial dome, if you will. I think it's more of a like a half globe, convex, and we're at the bottom. I think look, everything in the Milky Way is mapped out planar, with a small ecliptic. Even the solar system, it's all flat. Nothing's really underneath us in the universe. It's solar system, galaxy, universe. They don't really map it out as underneath us in most models. So I'm gonna say it's we're at the bottom, and it's it could be infinite. It could go out forever, just the same way you see your galaxy. I hope I was concise enough, man. That guy's put in a couple chats. I'll say it's dome-like. The universe is dome-like, but no, I see what he's saying, man. That's an interesting question. I could go either way, man. I could say infinite plane or dome, man, to be honest.
And what I'd say about a celestial globe, you've seen them with a model and there's a plastic dome with the stars on. That's just a way of representing it. I mean, the constellations will be drawn on there, but in reality, the stars are those constellations. As I mentioned in my intro, the stars are not connected in any way. They're not on any flat surface. There'll be varying distances. And in fact, with parallax, you can see some stars are close to you. Some are a lot further away. So therefore, it couldn't be an actual celestial dome.
You look at it mathematically, I'd have to agree, man.
Yeah.
It would have to be fairly
up down universe. Okay, if you think of the solar system, Brian, at scale, it looks fairly flat disk. But if you think, if you're stood at the North Pole, you look up, you're looking towards Polaris. You stand on the South Pole, look up, which is that way, you'll see another field of stars. There is no up and down in space. There just isn't. There's not a top and a bottom. It's going on, to all intents and purposes, and as far as we're aware, forever. And as far as we've looked at 14 point whatever billion years worth of distance, there's still stuff there. And it's accelerating away from us faster and faster.
Yeah, or else we're just at the center. You know, take your pick. It depends on the model once again, and you're going off of a mathematical model that's off 10 to the 120th.
We are at the center. Everywhere is the center. That's part of the.
Yeah, but they say we're still going to collide with Andromeda, even though we're spreading away from them. There's a lot of contradictions, man. Listen, I can appreciate the globe model and all that stuff. The scientists, the artists at NASA, all the artist renditions and that. But if you look into it, it's just little white dots on paper from radio telescopes that they say, like you mentioned the satellites earlier, like satellites orbiting. No, GPS satellites ain't orbiting. They're supposed to be in geocentric.
No, they're not. No, they're not.
They say they're in an orbit, right? They say they're in an orbit, but they call an orbit something directly over my head. They call that, what do they call that? Something that's directly over my head. What kind of orbit do they call that?
You're thinking of geostationary orbits, but they're not. They are just orbiting.
How can you call that an orbit, though? Geostationary.
Yeah.
We're getting more.
Okay, Brian, let me try and address that for you, okay? If you had, this is your Earth, here's your satellite. If it's geostationary, it's going around like that. So it's always over the same point. That's all. But it's
just sitting there.
But it's not sitting there. It's still going round. It's still falling all the time. And with GPS, sorry, Brian, I just want to explain. With GPS satellites, okay, one of my earlier phones, you could actually get a lock on the position of the satellites. So you'd see them as they come into the field of view of your screen and then off again. They're going over, so you'll lose one satellite, but another one comes into view. That's why there have to be so many of them.
Well, why don't they have GPS everywhere? Look, it's getting better. It's getting better. But, they just blanket covered South America with balloon satellites, okay? I got videos on it, and I pulled up all the information on the amount, the distance to each balloon covers, the height of the balloons. It's all in my videos about the satellite balloons. There's stuff. Listen, I admit there's stuff up there, but if I got a helium balloon on a string and it's just sitting over my head, how is that an orbit? If I don't think the Earth is moving,
that's not an orbit.
Well, you call it geostationary orbit. To me, it's just something not an orbit. Over our head.
No,
why would they spend so much money on these satellites when balloons are doing the same thing as we speak?
Balloons are not doing the same thing. A balloon on a very long string, as you put it, is not in orbit. It's just a tethered floating device. You should
look up Governor Long.
A geosynchronous or geostationary satellite is traveling at great speed. It's not locked in any position. It's traveling at great speed, but it just happens to be that equates with the same position of the Earth beneath
and it also just happens, it appears to be the same speed as a damn high altitude airplane. But look, you should look up Governor Long from Louisiana's when he read over the Satellite Act, the Communications Act of like 1960 something. He said at first he thought when he was reading over it that it was as crooked as a dog's hind leg, but after reading the whole thing, he now sees it's as crooked as a bag of snakes. The Satellite Act, all this satellite information, 99.9% of it's through underground cables, okay, and towers, okay.
Well, I'd have to say
I'm not denying there are things up there, Mr. Sensible, but all we get is cartoons, man, and I'm a skeptical type of guy, man.
Right. So I'll have to say I've never heard of this Satellite Act at all, so I don't know what that is at all. And with regard to satellites, you can watch satellites go over. There are websites. I've used Heavens-Above. I forgot what the last bit is, but Heavens Above. And of course, the ISS. Not only can you see it, I have filmed it with my phone before now. And what's his name? Geronism filmed the ISS both on a lunar and a solar transit. And you could see the shape of it. It's real. It's up there. It's predictable.
I'll try and get you that information because it's not called the Satellite Act. It's something like that, though. But
Well,
I remember the
email it to me
damn
afterwards.
governor. I remember the state, the governor, and all that, and forgot the damn name of the bill.
Email it later. Email it later.
And on that note, going back into regular questions, keep on sending your super chats in, but ask Brian about sunshine on the bottom of clouds.
Like I said, they don't have the angle on a heliocentric model. You're not going to get the angle if the Earth is curving 1 degree every 69 miles. You're not going to have the angle. You know, if you go to P-Brain, whoever is asking that question, just at least look at our explanation. Go to P-Brain, P-B-R-A-N-E, and look at the photographs from the top of Mount Rainier, and you'll see it's just perspective. When I first seen the clouds and the sun, and you know, that was a pretty compelling argument. But when you see the light above them, when you take the same perspective from the mountaintops, you'll see what you wind up is the devil's in the details. You'll get flat Earth proof.
I've seen P-Brain's video about the shadows of the mountains on the clouds, and he just can't 3D. He's getting things upside down.
I think you got it backwards, man. That's my opinion on that. Like I said, I like seeing the evidence. So when I see the pictures from up top there, the actual evidence, not just one from the ground, I like seeing it from every angle. When you see the angle from up above, you realize it's perspective.
And that's a perfect transition for our next question. Robert's really coming after you. Can Brian please provide the mathematics for his claims?
Man, I don't think the mathematics proves anything, but I'll say, you know, I made a little refraction model with math because it bothered me that Polaris would have to be, you know, not until you get to about 40 degrees or so, but it'd have to be in multiple positions. So there had to be an explanation and simple refraction, which we both sides would agree we always have refraction, and just a little bit of refraction due to the humidity gradient solved that problem real easy. But that doesn't prove that the Earth is flat. It's a model, but math doesn't prove things. People, we could do a math on Superman flying. You know, I've heard that example before, but it doesn't prove there's a Superman, and it doesn't prove he could fly. Math.
Well, with that Polaris thing, though, Brian, again, you're saying about refraction as you get lower towards the horizon. Okay. Forget that. You move 1 degree, move 69 miles, Polaris drops 1 degree. If you move 5 times 69 miles, Polaris will not have dropped 5 degrees. It doesn't work on a flat plane.
No, it doesn't work on your model up until 16 degrees.
No, it works constantly.
Please quit acting like it works on a globe. It does not work on a globe.
Right, not only does it work on a globe, it cannot work on flat, and it's another perfect proof that it has to be a sphere.
It doesn't work on a globe, okay? Look, we start seeing all kinds of perspective. That's why I started off with asking you about the stars separating, because you're going to boil it down to refraction because it doesn't work. You need to bring in a variable because it doesn't work. I call it perspective along with refraction of why we see Orion like coming up faster toward the edges even when it turns, when it's on the horizon, and it differs on certain days. You attribute it to refraction, but that's because it doesn't work, and you need a variable to explain it.
Well, I already told you right at the top. I deny that the stars diverge from each other with that rotation, and you'd have to explain how in the northern hemisphere the moon and constellations such as Orion appear one way up, but if you're in the southern hemisphere, they appear the other way up. That wouldn't happen. That wouldn't happen
in your video.
Last word, Brian.
Okay, in your introduction, you showed a plane looked like it was traveling right toward the Milky Way, but it just kept on going the same way. Or if you didn't, I thought I seen the Milky Way and from an airplane in yours, but I was going to put it in mine. But the Milky Way, it just turns in one direction. It depends on which way you're facing. But like I said, you agreed with me at first that stars deviate to the north and to the south and overhead at the equator, and I think it's easily captured. That would indicate there are at least 3 separate star rotations. But I think, I'm not 100% sure on that. There's a few explanations. To me, there's more than one star rotation, and you can demonstrate that in water. If you sprinkle pepper and put a charge in some lightly salted water, you'll get two opposite rotations one around the one polarity, one around the other. And you can see the pepper, and they demonstrate the stars. One will go around the positive side of the battery, and the other flakes of pepper will go count the other rotation, I think clockwise, around the negative side of the battery. So
perhaps the Earth in my video then has been lightly salted.
Yeah. Maybe the Earth's a battery. Hey, who knows, man? Lightly salted. That's a good one.
And okay, getting sent right back to the top. Mute Decibel with another $5 super chat. Brian, you keep sending us to different places for a concept. Can you please walk us through just one model that compels you?
Talk is cheap, man. Talk is cheap. I like to show things, especially over at Brandon's channel. I keep mentioning it, but we like demonstrations over there. I could say one model. Man, you're talking about terabytes of information, man. How can I just say it? I can pull up a picture of the sun, the heat tracks, and just a basic model of temperature and air current and all that. When you're talking about model, that's a pretty broad term. Would you agree, Mr. Sensible? I mean, when you say model, that's a pretty broad term, ain't it?
Well, I think I can sum up our understanding in a model. Earth is an oblate spheroid rotating just under 24 every 24 hours, orbiting the Earth at 364.75 days or whatever it is. And Earth and all the other planets are roughly spherical because gravity causes them to collapse, and a sphere is the smallest shape. The movements of the stars, the apparent movements of the stars in the sky, I'm talking about, the movements of the planets, retrograde orbits of the outer planets, the fact that Mercury and Venus can only be seen for a short while in the morning and evening, indicating that they're close to the sun. All of it gels, all of it will fit together. Things like the mountaintops lighting up first at dawn and staying lit till last at night. That's no more than the light just peeking over the edge of a ball.
Right, let me get final say on that.
Everything ties up. There's a quick, simple model.
Let me get final say on that. Okay, I'm just going to say, okay, the Earth is a stationary plane. The sun gets closer, shit gets hotter. Sun goes further away, shit gets hotter. Shit rotates over our head, okay, just like we see it.
And on that note, question from Nikki: all the pics of other spherical planets are fake? Question mark.
Nobody, I don't think they're fake. I got footage of Jupiter and the little dots around it that go back and forth. Nah, man, that's part of the mystery, man. And embrace the mystery of the heavens.
Well, I'm glad that you sort of say that the planets and spheres, Brian. I'm pleased that you've looked at Jupiter and seen the main moons. I mean, you said moving backwards and forward. In fact, they're orbiting, so they're crossing in front and then going behind. So yeah, I'm genuinely pleased you've looked at that. So if all these moons and planets are spheres, they are showing orbits that you can predict. Why can't you just take that final step? Why can't you take that final step?
The moon certainly appears. The moon certainly appears.
Brian, why can't you just take that final step and say, and the evidence also shows that the Earth is a sphere?
Because NASA's full of shit. They've been caught lying. Look, man, go look at the Jupiter. It's nothing like what we see. I mean, is the red spot tidally locked to Earth or something? Because it doesn't rotate fluently like they might claim. I mean, look, when I see Jupiter, okay, then they show me the 2012, and then 5 years later they show me a nebula above it, and it matches exactly. Then that means somebody's full of shit and showing me a lie. Okay,
well,
I don't hold them lies lightly. and they're all over the place. And when somebody lies to me, I don't believe them. Okay. So
Well,
I'm not going to make the claim that they're spheres. They could be. I think they're a lot smaller and a lot closer, but
do you think the moon is a sphere?
It certainly looks like it.
It certainly does, because we can see more than just a flat face. But you mentioned the red spot. Different areas of Jupiter rotate at different speeds because it's a gas giant. It's like with the sun. We can watch sunspots. The sun, if you think of latitude lines, rotates at different speeds. Not just like the equivalent of Earth being your 1,000 miles an hour at the equator and a little less as you go further north. No, it's not even tied to anything like that. It's just totally different speeds.
Yeah,
and actually, it shows the sun is a sphere. Shows the sun is a sphere because you can watch a sunspot coming across the face of the sun, and then a few days later come back around again, showing it.
Yeah, but my point was, is if you look at the 2012 picture of Jupiter brought to us from NASA and them different observatories, then they show the nebula from the Kissimmee. Okay, now that's a 4-year-old photograph. Everything is identical. I mean, you will not disagree that it's identical. You'll probably come up with a reason why they're using the same photograph or something. But to me, you know, I see the blatant lie that they just happen to get caught.
Well, I would say, Brian.
Oh no, you're good.
What a shame you didn't bring photos like that as your presentation instead of those silly NASA papers, the assuming non-rotating Earth and the 8" per mile, which is basic stuff.
I got nothing against employees at NASA, man. I got nothing against people at NASA. I just think there's a few people up in the compartmentalization that are having to do what they're doing or think they have to bullshit, whatever.
Okay. On that, a big old $20 super chat from Daryl Jackson, sending so much love out there. Brian, the models have seen the sun/moon travel around the Earth in a circular pattern and are close to Earth. Why are they in that pattern, and why do they not crash into the Earth if they have gravity/weight affecting them?
I don't believe that they're acting on gravity. Why? I mean, I'm not going to, I mean, they keep asking questions about the heavens. I'm giving my opinions, but the sun, you know, look at quantum locking. We could demonstrate a circuit. I'd like for them to demonstrate an orbit. That sounded almost like a flat earther asking me a question. You know, to be honest with you, Guy, if you are a flat earther, if not, I apologize, but, you know, I don't know. It could be quantum locking up there. It could be magnetic fields. It's just been, they've been making the same paths for all of written history. It's for, you know, could be for signs and seasons. It's we depend on it. I know that for sure. And we travel by it. We map shit by it. We model shit by it. But to be perfectly honest, you know, I don't know exactly what it is. It got an apparent location. I'm certain of that, and that's all.
And all right, thank you so very much, Daryl. Sending love, but moving back into, we got like about a page more questions. So if you want to get your question in, now is the time to send it. From Robert, please ask Brian, what is bigger, the equator or the tropics of Cancer and Capricorn?
The Tropic of Cancer is, I got a video on that showing, I mean, I'm going by the sunsets. There's not a lot of places to judge by that. We've been trying to get people together to not do sun angles, but to do sun zeniths, because that would be the only thing where we could definitely rule out refraction and get actual sun speeds or whatever the sun is, that the apparent position speed at the equator and south of the equator. That would be another way to prove or disprove a model. But it would take exactly that. No angles, no shit like that. It would have to be exact distances, straight line distances, and zenith speeds. But I think to answer that question, I think Capricorn is pretty, to my satisfaction, provably bigger. look at the old shipping logs and stuff, man. Look at the flight routes, man. Why are I don't know. To me, the Capricorn is bigger, but there's flat Earth models where they're the same.
Well, Tropic of Capricorn and Cancer are the same size as each other, both of which are smaller than the equator. If the Tropic of Capricorn was larger, all the Tropic of Capricorn is the furthest point south that the sun is overhead, isn't it, on Midsummer's Day? That means the sun must be going faster to travel around a longer Tropic of Capricorn. Only it doesn't. It always travels across our sky at 15 degrees per hour. Thanks, Bob.
Or in your model, the Earth's moving faster or spinning faster. Take your pick.
No, because if you measure the speed of the sun down at the Tropic of Capricorn, when the sun's down there, it will still be going at 15 degrees per hour. It's not speeding up. And if it was speeding up, Brian, you've got to explain what is the force that has made it speed up. And when it goes to the Tropic of Cancer, what is the force that's made it slow down? And indeed, what's the force that made it change from circling over one to circling over another? And what's the force?
I could argue that all the southern oceans, the sun could gain more momentum over the oceans, than over land. But I'm just saying, listen, hold on. If you ever even seen the analemma, okay, the analemma, no matter where you go on Earth, there's a big giant circle at the bottom and a little loop at the top. Okay, that indicates if you 3D map that shit, it don't work on a globe, man. You can try and fit it into your rotations and all that, but the moon does the same thing, but we don't get the full thing because of the new moon. But it makes a bigger path at the bottom just in a shorter time. So you don't try and say the orbit of the sun, because the moon wouldn't do the same shit. It's another globe killer. There's so many globe killers. You just got to open up your mind and look at the damn things and not hear all the, just open your mind up. Even if the Earth is a globe, man, there's some splaining to do, man, on y'all side.
Are you really saying that the sun might speed up when it's over water? Because you could still see it when it's over land, yes. Which means it would be different speeds to different people depending where you are. Nope.
Yeah, but probably not.
All right, there we go. And question from Robert, still coming at you. Does Brian know the globe is angled away from the sun in winter?
Yeah, and that's another thing. You would think that the North Pole and the South Pole would have matching, at least semi-matching climates, but there is no plant growth south of like 65th parallel, according to everybody, even according to the globe model. Yet, during the winter for the southern hemisphere, during the summer, it's closer. So it's supposed to be the sun shining on that Antarctic ice for 6 months out of the year, and it's 3 million miles closer to the sun, yet it's a damn ice ball with no life except for in the waters and penguins. There ain't even no polar bears, for God's sake. The South Pole and the North Pole are nothing alike. The seasons work better on a flat Earth. And if you look at the flat Earth model of the sun path and the ocean currents, the temperatures, the winds, they all work better. I meant to get that in my modeling, but I didn't. But round 2, I'll try and bring some of this stuff instead of chalk.
Sounds juicy to me. And all right, from Amber Ray for Brian, is the Earth covered at all? Since to hit China with a bomb or anything in a long distance, you have to angle the rocket.
Could you repeat that? I heard it, but I want to try and be concise.
So for Brian, is the Earth covered at all? Since to hit China with a bomb or anything in long distance, you have to angle the rocket.
Yeah, there certainly seems to be some type of containment. It's, things get colder for the most part, okay? Get colder. It seems to be some type of containment around 70 miles up, maybe 100 miles up, maybe 5,000 miles up. I don't know. It seems to be a level ceiling. If the Earth is a a flat plane, which it certainly presents itself to be, it would almost mathematically it would have to be a flat ceiling up there, according to a lot of people and some of the like the second law of thermodynamics. If there wasn't containment up there, it wouldn't get colder up there. It would because you take gas pressure in one side of a container, like a 2-part container, and separate the pressure from a vacuum. As soon as you release the valve, they instantly, the side instantly fills. It instantly equalizes. There's no change in entropy. So there's no change in temperature. So if it was a vacuum up there and gas was escaping, it would be pretty much, about the same temperature all the way up, especially the fact that you're getting closer to the sun, the higher up you get there. And so I think there almost has to be some type of containment about 70 miles up. According to the heliocentric model, the Earth's on a diet, losing like 90 tons a year or some horse shit. And they have some type of, we bring up arguments about sending signals back in the late 17, early 1800s across the Atlantic, and they want to attribute the ionosphere at 60 miles. But then they want to say that the gas runs out at about 15 miles or 10 miles, but there's some type of ionized gas up there that bounces a signal. Everything's just so perfect. They have an explanation for everything, but I think a lot of it is just that explanation.
Well, you'd have to show this container. We've never, ever seen it, Brian. And why do you think we need a container? Even Mage at 38 3/4 kilometers had reached a point where only 0.3% of the atmosphere was there, wasn't it, Arnold? And it had no problem with the atmospheric pressure down at sea level. That didn't rush up there. And this ridiculous thing about, you said, a 2-part container with pressure on one side, vacuum on another. Well, yeah, when you remove the barrier, of course it's going to equalize. That's as daft as Oakley keep quoting this bromine example, where that demonstration shows bromine gas at one end of a flask and vacuum at another. Yeah, of course it's going to equalize. But at no point on Mage's flight up from 100,000 pascals to 263 pascals, at no point was there high pressure next to extremely low pressure. At every point, the pressure above and below was basically exactly the same. It changed in a very, very, very slow gradient.
Yeah. And you know what? I think we could make that part of our part 2, because I got so much to say about that, but I'll just simplify it and say, I could show you a gradient, okay, in containment. You cannot outside of containment. You can't even show me pressure without containment. But
I just did with Mage. I just showed you.
But look outside. There's got to be a container. We've got pressure there. If you just look outside and you see the pressure, that means there's containment. I can show you a gradient inside. I got a video showing a gradient inside of containment. And but hey, I'll give you last word on that. But man, we should do the part 2 on a half of it just on gas pressure.
Well, the last word then, Brian. Recently, the US was unfortunate enough to have those nasty hurricanes. The pressure drop, I believe, was something in the order of from just over 1,000 millibars to about 90 less than that. So way less than, my math is bad, isn't it? Is that 1% drop? Okay, but coming from sea level to the top of Everest, you got a 30% drop.
Wait a minute.
The hurricane had those horrendous winds because of pressures trying to equalize.
Did you just say there's gas up at the top of Mount Everest?
Of course there is.
Is there really? Is there gas? Was there gas 20 miles up?
That's atmosphere. At the top of Everest
wait. Why is there gas way up there, Mr. Sensible?
What do you mean?
That's not part of the cycle, 20 miles up. The cycle's gas is produced here at the ground. What's it doing 20 miles up?
What are you talking about?
You said there's gas up there at Mount Everest and 20 miles up. How is there gas up there? Ain't gravity supposed to keep it down? I'll tell you how.
No. Hold on. I was making a point, Brian. You've flown in an aircraft at however many thousand feet, way taller than Everest. There's air up there. That's gas. If there wasn't,
and it comes from the ground. That's the whole point.
But there's
that air comes from the ground. Air
It's a lot
goes
less,
up.
Brian. Most
Gas
of the
goes
air
up.
is
It don't go down. Gas goes up. It don't go down.
Xenon
It's
would
created here.
disagree
Listen,
with you.
gas is created at the ground and it expands in every direction. You understand?
Helium,
It's created
put
at
helium
ground
in a
level.
balloon, Brian. Put helium in a balloon, put it in a vacuum chamber, it will fall down.
No, it will barely fall down. And in your model, it's supposed to fall. Hold on. In your model, in a vacuum, that helium balloon that barely trickles down is supposed to fall at the same speed as a lead ball, yet it barely trickles down. And I also could argue that the type of balloon you have to get that helium to drop is one of them little water balloons that are so tight, the helium would be filling that whole chamber. Instead, it's condensed in that little tight water balloon before it pops. So I could argue, but the helium is definitely denser than a vacuum. I just did a video on vacuums.
Of course helium is denser than a vacuum. Of course it is. Because there's something there. But I cannot believe you questioned about there being
we gotta save
at the
some
top
of this,
of Everest.
Hey, Mr. Sensible, we really got to save some of this because there's so much to say, man, on this whole point. I know it was one of the topics, but we really should save some.
I'm stunned at that, but I think Amy's waiting to say something else.
I got some examples to show you, man. Okay, go ahead.
Hey, like I said, we're always looking for more examples and the excitement as it gets spicy, having fun. Earth is Life moving right to the front with a $5 super chat. Why does the globe model have an explanation for everything and flat Earth has an explanation for nothing? Question mark. Doesn't that tell you something? Question mark.
It wouldn't be a model if it didn't have an explanation, you know. But we don't live on a model.
Oh God,
we don't.
Don't say that.
Well, when you start talking about models, you start acting like that's for sure reality. And
no, a model is a set of ideas.
If you get right, it's a set of ideas. So there better be explanations for the damn globe model. Been around for a long time, you know. But some of them are horse shit, in my opinion. But at least they do have explanations for most everything.
And okay.
I got a lot of good ones. I got a lot of good challenges for you, but I want to show you rather than tell you. That's why I said we should save some of it for a part 2. I've enjoyed this, man.
Our silly question of the day: what is their favorite cheese?
I'll let Brian go first.
American.
Oh no, that isn't cheese.
Man, that's tough. That's tough.
Mine is Emmental.
There you go, ladies and gentlemen. We're getting to the real questions tonight. And all right, another question from Hal. Amy, how does Brian explain how we can calculate our latitude using the Foucault, that's Foucault, the Foucault pendulum experiment, if we truly live on a flat Earth?
Yeah, you can calculate it when it cooperates, but it deviates. It's not as accurate as some claim. But you know, you can get a you know, it's got to be an exact specific size. You know, there's points that have been documented, like during eclipses, where the pendulum just deviates and goes backwards. But I had trouble with my pendulum. I was never able to. I mean, you could do the math and get latitudes if it's acted just right. I believe there's more variables, so it's not always going to cooperate. And in my opinion, and by my experience, the Foucault pendulum is unreliable, to say the least.
And all right, another $5 super chat from Mute Decibel, and sending love to all of our supporters out there sending super chats. But Mute asks, Brian, explain the Aurora Borealis / Australia on a flat Earth without mentioning globe Earth, or cede its explanation to a globe Earth.
What was the second part? Not mention the globe Earth or seed?
So, explain the Aurora Borealis Australia on a flat Earth without mentioning the globe Earth, or cede its explanation to a globe Earth.
I mean, I don't see how the Aurora Borealis would work on a globe, so I'll avoid the globe part. But I mean, I'm sure there's once again an explanation. But I mean, it would probably be ionized gases up there. Same thing as how we get like pretty sunsets and sunrises. It'd be the gas gradient. The fluorescent gases up there in the upper atmosphere. If you look at a channel called, and I'm saying this in case people are interested, called Dan Dimensions. He takes all the gases and ionizes them, and just like they flow in terms of density, the colors they match the atmospheric colors, like the oxygen and the nitrogen are like a sky blue, whitish bluish, and then when you get to the lighter gases, you start seeing the different colors, and where hydrogen is like a purplish, I think, and helium. I mean, it's pretty neat. Dan Dimensions is the name of the channel. If nothing else, Glober or Flat Earther can enjoy it alike, whether you agree with it or not. But let me touch back on the dome. You said there's no evidence of the of containment, and I would disagree. I'm going to save some of that for the next debate to bring visual evidence. But we've seen sprites, we've seen the rockets appear to enter some type of medium. There's more evidence as I'll bring visualizations if and when we have a part 2. But I would say there is evidence for containment. Thank you.
And all right, another $5 super chat from Earth is Life, trying to bring the entire channel into agreement. He says, I'm not too sure about that, but I do like fairy kittens. So,
top man.
We can all agree.
That's funny, man. You know, that
you need to watch my channel then, Brian. You need to watch my channel.
Go ahead.
I was saying you need to watch my channel, and you'll find out more about that.
I've watched I'd say almost half your videos, man. I'll speed through some of it, but I try and catch a little bit of everybody. To be fair.
Oh, excellent! We'll have you as a patron before the end of the month, then.
You might, man. You just might. I do, like I say, I admire some of the work you've done, man.
Thank you.
You know, I enjoy this debate. Your temperament is great, and
I've enjoyed it too, Brian.
I get passionate sometimes, so it's good for me to keep it within realms of calm and collective, man. But I want to say I would really like to do this again, man. I hope we put on a show, but I have a lot more in the bag, man. I want to say one thing about that guy with the Foucault pendulum. I understand the math works good. Look, with the sign, I understand you could do the latitudes. But do yourself a favor and hook yourself up a damn pendulum, and if you have it, and see that it's unless I'm just doing something completely wrong, it just wasn't that reliable. You know,
need a very long pendulum and it needs to be a heavy pendulum swinging slowly for quite a long time. It's not the easiest thing to do.
The pendulums in the museums are electromagnetic. You know, they don't even deny that. Maybe they would work.
That's just to give them a kick.
Show.
That's just to give them a kick to keep them swinging, because obviously otherwise they would eventually come to a halt.
Yeah, well, you know, I still recommend that everybody try some of these things they've heard.
Well, that's never a bad idea.
Question from Amber Ray: why does the Atlantic cable shown to be curved? Seems to be curved. One of those. Has shown to be curved. Trying to add in a sentence or a word.
Yeah, it depends on how you map it. You know, depends on how you model it. I've been surveying my whole entire life, not over long distances, but every job I do, I survey. I work in level and flat and level. That's my job. I've been doing it for over 30 years now, and I have the equipment. And so when I went down along the beach, I had a couple of Globers tell me that because I was getting equal elevation above the water.
Surprise!
They said I was curving around a globe, and I just didn't know it. And I'm thinking I'm keeping a nice tangent line, or not a tangent. That would be to a ball. If it's a globe, it would have had to have been a tangent, but it wasn't. It was equal elevation. Granted, I didn't even make it 2 miles, because I'm like, how can it just start curving? I'm just going, it's equal elevation, you know, above the coast. And I just gave up. I gave up, but they said that I was curving. I was shooting my way with an auto level around the ball, and that I just didn't know it. So they say they had curvature corrections. So that's when I looked into it and found out you could model it either way.
Well, I was going to say, Brian, what did you use to establish level, an auto level? I'm not sure of the actual internals. Do you know what it is that actually makes it decide that's level? That's level.
Yeah, there's a plumb bob in it.
It's a plumb bob, which operates due to gravity. So as you move further, but as you move further round, your perpendicular has changed. It's still...
That's why. I understand the argument. It's a good explanation. It's fair. It's definitely a fair explanation. But so I come up with an idea of setting, and actually a guy did this with lasers. He set up multiple. They have something called double rodding to double check it's twice as effective of maintaining a horizontal. But I was going to like do a experiment and triple rod it and use like 6 backside and foresight to make sure I'm maintaining a horizontal, but I haven't done it yet. To me, I've seen enough out there on the coast, but for myself to see that. But you know, some days I look out and shit would look obstructed. It'd look like curvature, and then I realized that that's just obstruction. That's not curvature. When we measure it, it's not. But it could be. I understand the explanations.
Well, Brian, you shouted out a lot of channels, so I'm going to shout out one. A guy called The Maine, as in the US state. The Maine state or town, whatever, you know, Maine, The Maine Surveyor. And he is a surveyor. And he's got a video, and I forget the exact term. I think it's the sum of the zenith angles, basically taking readings and showing that those verticals are not parallel, and that can only happen. Yeah, I know, but it's worth a look because he is a professional. He shows you how to do it, and he shows the maths if you understand and follow. I followed most of it.
I understand the maths on that, but that's how that's how the Earth was modeled. That's how the globe was modeled. Was by the sun. You know what I'm saying? So, you know, there would have to be, in a flat Earth model, in my opinion, there would have to be that refraction model. That's why I came up with that.
I don't think he's using the sun.
I had to mathematically satisfy myself for the angles to the sun, to Polaris, to the moon, all that. And it just took refractions off. There's other explanations in other models. To me, I had to do it mathematically to come up with a, you know, for it to even be feasible. But
check out the Maine Surveyor. The Maine Surveyor, recommended.
Yeah, he's tipped his hand a couple times. They don't practice some of these things they're saying they're doing. That's not part of their everyday practice. That's not saying he didn't do these things and that they don't match. But they break down, like I said, at 15 degrees, and they shouldn't. They shouldn't consistently break down. You could attribute refraction to a little bit of it, but it starts when you get toward the horizon. Shit starts lingering. It starts pointing toward a flat Earth. It's what would happen on a flat plane. The sun would linger, stars would linger and shit. I understand you'll have a reason, but it's also what would happen on a flat plane, man. Is things would linger on the horizon, man. That's my, just
all right.
Put it out there.
There we go. And then our new record, send in love to the Missing Curve with their $35 super chat. Send in so much love for the support. Mr. Sensible, when in the southern hemisphere, why does it get darker quicker after sunset? In the southern hemisphere in summer versus the northern hemisphere. I'll read that one more time. Big old please. 35. Mr. Sensible, when in the southern hemisphere, why does it get darker quicker after sunset in the southern hemisphere in summer versus northern hemisphere?
I'm not entirely sure. My understanding is that near the equator, night falls a lot quicker. Is that what you're talking about? The speed of sunset, or are we talking about the length of the days? And less night. I'm not entirely sure. I'm sorry. I'm not trying to avoid it. I'm just really not sure. Does it? You know, I don't know. So I'm going to have, I'm afraid, to pass on that. Not because I'm trying to avoid it, but because
let me butt in real quick, man.
Please do.
I think what he's talking about, like right here I'm in Florida. I'm about 30 north latitude, like 29 and a half or something like that. It's 6:11 here, and it won't be dark until after 9 o'clock. The daylight just lingers. It lingers. Where in the southern hemisphere, it doesn't do that. I mean, I think that's one thing. There could be an explanation like mountains or something like that, but I think there needs to be an explanation for that. Why the sun just lingers here for hours and hours, even though SunCalc has it set and everything else, still the daylight lingers.
Yeah, but I mean, that's the same here in the UK at certain times of the year. I mean,
you're in the north.
Our days and nights, the lengths of them vary greatly throughout the year. And the further north or south you go, the greater that effect is, until you can end up getting 24 hours of darkness, 24 hours of sunlight. But I'm aware that was a super chat. I have tried to answer, but I have to say, I'm being honest, I'm really not sure. It's not a comment or argument I've heard before, so I'd have to look into it before I could either agree or disagree, really.
$5 super chat from Mute Decibel. Brian, so why are these ionized gases, the aurora, local to the North and South poles?
Let me think.
Quick, Google is your friend.
Yeah, that's a good question. I mean, it would be a self-perpetuating molten iron core on a globe, but he doesn't want a globe answer. I think it's just maybe the magnetic field of the. I've never really seen the Aurora Australis, but they've named the son of a bitch. It must be there. Maybe it's just so damn cold, man. I'm gonna bring a little bit of that to my next debate of extreme cold weathers and what happens to different materials, some new science on what happens to light, what happens to some of the gases under extreme cold. But man, that's a hell of a good question, man. You kind of got me stumped on that one, man, to be perfectly honest.
Well, the Aurora Borealis and Aurora Australis are nowhere near the Earth's surface. They're really up quite high, and it's not to do with temperature. It's the Earth's magnetic field diverting the solar wind towards the polar regions, and as the particles get excited and start glowing, and that's what you can see in extreme north and extreme south.
Yeah. But why ain't there Aurora South Americas or Aurora Africus? You know.
Because the magnetic poles are over roughly the north and the south.
Yeah, there's anomalies all over the place, man. I'll bring that up in the next place. The whole entire eastern coast of South America is called the South Atlantic Anomaly. Damn near the whole entire coast. I could explain, some of these satellites. I mean, I got a whole nother pocket full of problems that you might or might not have good answers to. But that's a good one. I've never, magnetic field. I have no reason to disagree with the fact that it's magnetic, and because if it is as cold as they say in them regions, then I would think that ionized gas would migrate that way due to the second law of thermodynamics just as much
it's not the temperature. Remember, it's not down near the surface where you've got the Arctic and the Antarctic. It's however, I don't know, 100 miles up or whatever it is. It's way above. It's not anything to do with temperatures down here.
Yeah, well, maybe it's the container.
And on that, another question, super chat from Daryl Jackson. Brian, since a lot of flat earthers like to bring whole ships back into view, why can't you wait for the sun to set, zoom in, and bring it back?
I think once light is lost to the unaided eye, it's gone. And I'll give you an example. Take a piece of plywood and cut a hole in it, like 2 foot in diameter. A big old piece of plywood, let's see, 4 times the normal size. Cut a hole in it. Start backing away from it. Okay, you're going to start losing stuff due to that hole. You know, you could zoom in once you get far enough away and you see through that diameter. You could zoom in. You're never going to see around the corner of that hole. In other words, once the light is lost, there's no zooming it back. We can zoom back the angular size of things. And I could argue that, yeah, when the sun's on the horizon, man, you zoom in and you'll see a gap between the horizon and the bottom of the sun. That's been demonstrated. That's one of the flat Earth proofs, is zooming in on the sun, showing the gap between the bottom of the sun, and it looks to be setting. But then when you zoom in, but once it's set, that's it. Once the light's gone, it's gone. That's obvious in either model.
Yeah, and once a ship has gone round that curve as well, it's gone. You will not ever be able to bring it back. You said once the sun is gone, you're not going to see the light with the unaided eye. What that super chat was talking about is why can't you bring it back with a telescope or a P1000, a flat earther's camera of choice? Because you are zooming in. Your eye is no longer unaided. And
I got to call nonsense on that.
It would be one thing to say, you know, if you could demonstrate that the sun gradually fading out or shrinking to an absolute point, that would be one thing. But it's not. You can see endless photographs of the top half of the sun. Bottom half has gone. So that's nothing to do with perspective or anything like that.
Wait a minute.
And it's got the same angular size. I'll just finish off. When it is half and half at the horizon, if you took that diameter across at the horizon and compared it with the diameter of the sun when it's overhead, it's the same. There is no reduction in angular size.
As things go away from us, man, they get bigger. The atmosphere acts as a lens. Okay, I'll bring that. If you don't believe, I'll show you meteorologists saying the atmosphere acts as a lens. It magnifies. Okay, so the sun gets bigger on the horizon. In most places, but it always varies. If you want to get a filter and say the exact shape and size, whatever the sun. And we can show you variations in that too, smaller, but still variations. But, my argument would be is that, weather, a change in weather can bring a ship back. It's not Earth curve blocking them ships, okay? Even if the Earth is a ball, it's bigger than they say it is, because I've got a P1000 and I go out there on the water all the time. I go out there with my auto level, and there's a new argument coming up from the Flat Earth, and you could get it sooner if you go to Brandon's channel, but there's a function of mathematics just with angular. I'll save that for next time. But look, weather can bring ships back. Just a cool front coming in can bring a ship back into view that's blocked by what you call Earth curve. I've got video of it. I haven't posted a lot of that on my own channel because Travis does most of that. But maybe I will post some. But you can see mirages coming in and out. What seems to be the curve of Earth going up and down. There's videos of skunk. There's videos of Skunk Bay showing shit just go up and down. It's not Earth curve. It might be some water waves and shit like that, but it's not Earth curve, man. It's refract. It's the atmosphere.
Well, obviously, refraction does vary with temperature, with the gradient of the temperatures and densities of the air. Of course, it does. It varies within a small amount. So sometimes the horizon will look a little closer, sometimes a bit further away. But there will be a point beyond which, even though the object is large enough to be seen, like a supertanker, unfortunately, at that distance, you can only see the top half of the supertanker because the curve of the ocean is in the way. It's blocking.
I encourage you to go check the distance that happens, and you'll be fascinated, to say the least. You need to know the refractive indexes to be able to be sure. Check out Walter Bislin's channel for things like that. You wouldn't believe how far. I'm just saying, I've recorded them for hours, dude. They go forever. I live right here by a main port, and these tankers come in and out every day, and they go forever before the bottoms start coming up. And they don't always do that. They disappear different there's like 5 different ways shit disappears, man. It really is. You could call it Earth curve and refraction combination, but to me, man, it's obvious that it's a flat plane. If it's a sphere, it's a lot damn bigger than they say it is, man.
And if it's a flat plane, if it's a flat plane, things would never disappear. Horizon, they would gradually fade off into a fuzzy distance. And I see Amy's ready
Brian,
to read
last
something.
Word.
Oh, don't go back to 2015 on me. Don't make me Black Swan you, man.
There we go. Moving right along. $5 super chat from Earth is Life. What's the difference between plane surveying and geodetic surveying? Geodetic. Which one are you?
I mean, of course, obviously, planar surveying, but geodetic surveying is, is more for mountains, like mountain elevations and state lines, like borders. You know what I'm saying? Like the borders of cities, the borders of states. Planar surveying is for like elevations of towns and cities, and even statewide planar surveys. Like I said, man, we can't prove that either way. You can model it either damn way. You could say that it's flat. This is where the debate is progressing to, is horizontal what it claims to be by definition there, because you could model it either way, man. But the experiments like the main surveyor Jesse Kozlowski and all them, they're using 7/6R and all this stuff because Earth is flatter than it appears. They're saying that there's more refraction at night than there is when the sun's overhead, and the temperature gradient's even more, in my opinion. So these are the arguments. This is where it's progressing. So I think we should probably table that as far as the surveying and stuff goes for round 2.
And all right, we are going to finish up the questions in the Q&A section and then let both of these guys have their final statements. But Ryoko asks, I was asking if the flat earther can show a city or town over 2,000 miles away, ? If things come back over the horizon when you zoom in, you should be able to.
Okay. Picture this. Picture you're looking through a scope, okay? I got a tool called an auto level, okay? It's an auto level, and what it is like Mr. Sensible said, it's got a plumb bob inside of it. It pretty much marks the crosshairs, okay? So you know that them crosshairs are looking directly straight out, no matter how high you are. So if I'm at 5 foot, them crosshairs are looking out 5 foot, as far out as you can see. Well, if way out in the distance the Earth starts curving down, that's not what I'm going at. What I'm getting at is picture on a flat plane. I'm 5 foot above the ground, and my shit.
Completely understand.
And I completely agree with the very last thing he said.
And that's okay. Do you still have your sound? Because that's the most important, I will say. As much as we love looking at everyone's lovely face, I'm gonna see if there's a question for Mr. Sensible. We'll give him a minute. Though sending love to all of you guys out there in the internet sphere on Modern Day Debate. We are having fun in our flat earth between our two interlocutors.
I'm wondering if his phone battery's died.
Uh-oh. That might be true. I have to do like a 2 scene to fix it.
I just see a comment aimed at me in the chat. It's back a little way, I guess, because of the delay, from Mark saying Mr. Sensible is a rookie. He's just parroting the same thing. Well, unfortunately, Mark, the evidence doesn't change. So, yeah, I'm going to say the same things. But there you go. But thank you for the comment.
We got some questions from Church of Entropy.
Church of Entropy.
For Mr. Sensible, given that empiricism supports flat Earth, what is your best non-empirical argument in favor of the globe?
Supports the flat Earth. Well, I mean, the easiest thing, or the most obvious thing, is the fact that everywhere you look, we've got balls in space, and there is no reason for us to be any different. There is nothing to show that we are different than that. Looking and saying that looks flat is not evidence. It's not argument. You need to take measurements, and all the measurements and all the explanations for things like ships going over curves, for sunrises, sunsets, underlit clouds, and all that. As I said before, and I'll keep saying, all of those tie up together. Now, Flat Earth may come up with some idea for, well, the reason for the sun shining under the clouds is so and so. Okay, fair enough. But then that idea will contradict the explanation for something else. You can't have a theory, a model, where everything contradicts every other thing. They've all got to agree. Otherwise, your model breaks down. And Travi Bear says we have circles in space. You can't prove they are a ball. Well, actually, for instance, with the moon, well, yes, you can. With the moon, we actually see about 54% of the moon's surface due to an effect called libration. So during the lunar month, it actually turns and shows us more of the left and then the right of its face. So we know that that is a ball. Also, craters are foreshortened, so they look more elliptical as they get towards the edge of the moon. Planets like Jupiter, we can see things like the red spot as it travels around Jupiter and then comes back the other side. Same with the sun. We can see sunspots. We can track them across the face of the sun, and then a couple of weeks later, or however many days later, they reappear and come across the face of the sun again. So unless they're going off a disk and then jumping back, there's no explanation for that. Also, the moon would appear as an ellipse. If it appears as a circle to me, you're some distance away, it could not appear as a circle to you as well. These things are spheres, or oblate spheroids, depending on the actual body that you're looking at.
Woohoo! All right, if you have a burning desire question for Mr. Sensible, now is the time to send it in. And if not, we're going to move into our outros, and it has been a blast of a debate. I think Church of Entropy had one more question. I'm trying to look for it. Atmosphere. I can ask some. Maybe you have answers in the opposite direction.
Okay.
We'll go with... Oh, no, Missing Curve also has another one for you. Here we go. Mr. Sensible, how do planes land on north to south runways? And how does Polaris line up in Georgia guidestones? And we traveling at over 1 million miles per hour through space? That was broken up into 2 or 3 parts. I'm going to read it again.
Yep.
Mr. Sensible, how do planes land on north to south runways? How does Polaris line up in the Georgia guidestones? And we're traveling at over 1 million miles an hour throughout space?
Okay. North-south planes. Yeah. If you've got a runway facing north-south at about the point of the equator, you're also traveling sideways because you have conservation of momentum. And also, the entire time they're flying, they're making adjustments. There is no reason for the Earth to spin away underneath you. I think someone may, I don't wish to be rude, but hopefully you're not been listening to Mr. Nathan Oakley, because he does not get conservation of momentum. So yeah, there's no issues with whatever directions the runways are. You're going to get a greater effect from any crosswinds. Polaris with the Georgia guidestones, I mean, they're a fascinating thing, but yeah, Polaris will have been lined up. When they placed the Georgia Guidestones, they'd have lined it up with Polaris. That was what they wanted to do. And since Polaris, which actually draws little circles in the night sky, it's not a perfect, we don't have the stars rotating perfectly around it. The position of Polaris is not changing. These distant, I think off the top of my head, Polaris might be 900 light years away off the top of my head. These distances are huge. To link that with your million miles an hour, against what? Speed isn't a problem. And the distances are so vast. I did actually work out if we were traveling, if the sun was traveling at that sort of speed towards the nearest star, how many years it would take to get there. I can't remember the figures, but it's a lot. Space is, like I said before, space is big, really big. You might think it's a long way down the road to the chemist, but that's just peanuts compared to space. It's all scale. And I showed Barnard star, and you can see movement on that. And that's the star with the greatest proper movement across the night sky. And that was a 16-year stack of images. So yes, stars are moving, but it takes a long time. Yes, Polaris is moving, but it's going to take a long time to be noticeable. Maybe tens of thousands of years, depending on the direction it's going and the speed and so on.
Question for Mr. Sensible. How is Arnie doing?
Arnie's great. Let me get Arnie.
Hey, man, a cat knocked the phone right out of my hand, so we're going to have to let it slide.
Yeah, well, forgive me for that.
Cat.
That was
this
me
is
last
Arnie.
night.
This is Arnie, Slayer of Flirts. He's a baby, he's absolutely gorgeous. I've just woken him up twice, though, this stream, so he's not too happy. No, he wants to go back. So Arnie's fine. Thanks for asking.
Woohoo. And all right, ladies and gentlemen, we got 3 more questions.
Just before you read it, can I just very briefly point out something? Just caught my eye. Mark has again said, Mr. Sensible, your high altitude video with a fisheye lens, you admit it to be a fisheye lens, but NASA didn't. It's not fisheye. Fisheye is the grossly distorted lenses. Wide angle gives you distortions. That's why when you see high altitude balloons that are using those, sometimes the horizon tends to flex. I used a narrow angle lens, most definitely not fisheye. That was the whole point. Okay, thank you. Yeah, go on, Amy.
Woohoo! Thank you so very much. And a super chat just coming in from Earth is Life for $5. No, Brian, the difference between plane and geodetic surveying is geodetic surveyors take the curvature into account.
Yeah, longitude, using longitude. I asked earlier that don't use modeling to prove your model. I asked that earlier. That's basically what he's doing. Yeah. I could model it to be a globe, okay, but that's not how it was originally done. Okay, they apply curvature correction. Sound familiar? Curvature correction to match longitude. Okay, you're not going to map longitude on anything flat. Okay, it's going to make a ball. Like I say, Decimal Z made a sphere out of his tabletop. Once again, he modeled a sphere on his desktop with all the lines, the measurements, precise. Go to Decimal Z. It's doable. Okay, don't be fooled by the modeling. Thank you.
Woohoo! And all right, ladies and gentlemen, we're moving in. This is the end game. Twad Wazzle asks, follow in queue for Sensible. Have you alerted academia that the radius has been debunked so they can't edit the heliocentric model?
Now, I don't know if this is someone teasing me or if it's Mitchell from Australia's, one of Mitchell from Australia's crowd. During a debate talking about the Black Swan, I said, if everything you have said is correct, then at best you would have debunked the radius of the Earth, not that it's not a sphere. But I keep getting cherry picked as saying you've debunked the radius of the Earth. It's
Same
rubbish.
thing.
It's just a cherry pick. It's the lowest of the low. But I keep quoting Mitchell of
Oh,
Australia.
you call it low, the same thing as
Hold
thanks,
on, let
Bob,
me finish.
right?
Let me finish. I
Okay.
keep quoting Mitchell from Australia when I asked him for an explanation for 2 points of stellar rotation in the night sky, and he said, "I'm sorry, I haven't got an explanation for 2 points of stellar rotation in the night sky." So yeah, I just keep countering with that because that's a direct quote. His is a cherry pick.
That's just same thing as Bob. Bob never said there was a 15-degree Earth rotation. He never one time said there's a 15-degree Earth rotation. He said the device picked up a 15-degree rotation. So now you understand. It's him cherry picking. Thanks, Bob. But you get a taste of it. Everybody gets a taste of it.
Yeah, cherry picking is below the belt. But in fact, he said it picked up a drift of 15 degrees per hour. And actually,
yeah,
in fact, I wish he hadn't said that because that implies that the gyro was drifting. It's not. The gyro could be sat on the floor.
Bob said.
Hold on. You could have that gyro sat on the floor, nailed to the desk. It would still be registering 15 degrees per hour. It's not drifting. It's not moving. It's just that everything is rotating at 15 degrees per hour.
So why is it only picking up side to side? Listen, this has been going on.
Rotating in one direction.
Hold on. This has been going on since the Michelson-Morley and the Selenium Effect. Okay, they don't use that as proof. Einstein didn't use it as proof because it busted the globe. It killed the globe. Okay, just because they cherry picked Bob's words, you think he was lying about all the other results and how it changes when you go up an elevation a mile? Okay, no, he's being honest about everything. He was being honest, saying the device picked up a 15-degree rotation. But when we see the sun setting, we're supposedly falling over backwards, like I said, 1,000 miles an hour. Okay, why isn't it picking up z-axis rotation? The gyroscopes admit they do not pick up z-axis rotation, which is the way we're said to be rotating. Take away 23-degree tilt.
And sorry, once again, Mark is saying, and I do want to pick him up on this. He's saying your Mage launch, you had 2 cameras. One you claim to be fisheye, which shows perfect sphere. You admit it to be so, but ironically, NASA shows the same sphere. Is it fisheye? No, there were 3 cameras. There was a wide angle, not fisheye, pointing upwards to the balloon. There was a wide angle, not fisheye, pointing backwards just for the great view. And that bent and flexed. And a narrow angle pointing forward. If you want to debunk me, please do. You can have a look on my channel. I've got a Mage playlist. There's Mage the Results, which is cut down to about 45 minutes, which explains everything. But I've also got the full uncut footage. If you want to debunk that, please have a go, because I think about 8 people have done videos trying to, and only one, and I'm going to give him a shout out, Brian's Logic, had any valid complaint about anything, and that was just a minor detail with the temperature, and I've acknowledged he's probably correct about that. But do a video about it. Debunk me. Go ahead. Make my day.
Question from Hal. I wanted to ask Brian why we can observe satellites being eclipsed by Earth's shadow if the Earth is flat.
No satellites are being eclipsed by the Earth's shadow. They're going out of sight. If you want to talk about satellites, we'll talk about the ISS. You talk about the sun should change in angular size. The ISS is supposedly moving at 17,500 miles an hour, and we see it for up to 7 to 8 minutes, meaning it's traveling off the coast of the United States all the way to the other side. But it's about the size of a football field. You're saying things change in angular size up there? You need to go research your own BS, okay? Because we would never see something the size of a football field from one side of the United States to the other. And that's what your model dictates, okay? I mean, who knows what it is, okay? What they're showing us ain't it. The people on the ISS, I mean, there's so much fakery going on, man. That's one of my pet peeves is all the shit they've showed me, man. It's upsetting. The curve, whatever fisheye lens they use, whatever bullshit curvature they use with the ISS lens. The ISS could barely even see Florida and Georgia, and it's showing what looks like to be a planet. That's dishonesty. You call it what you want. That, to me, is dishonesty. Show us what it really looks like up there, if you are really up there. Show us people floating around for more than 30 seconds before you cut it. And I don't know. They got astronauts getting stuck upside down on wires. It's embarrassing. It's embarrassing to watch, man.
Right. You can see the ISS because it's a very, very bright light against a black background. Satellites and the ISS do disappear into the Earth's shadow because quite often you'll only see the ISS appear at some point above the horizon and disappear again as it goes into shadow long before it reaches the other horizon. And those angles are all calculated, and the predictions will tell you the start time, the height above the horizon, the end time, and the height above the horizon that it will disappear. And you said about 30-second clips. Yeah, you can see continuous clips of filming on the ISS way
Give me $72 billion. I'll do the same in every city too. When I see a plane flying across the sky at the same speed as ISS, roughly, I see something flying at the same damn speed as the other light. Okay,
it's a bit closer, Brian. A plane's only a handful of miles up.
And okay, that's the last comment on that. $2 super chat just came in from King Ed the Fifth. Bob picked up the drift from on 3-axis. Let me try that again. Bob picked up the drift from on 3-axis. Axes?
Yeah, I don't know if Brian's disappeared. Yeah, I don't know why he kept saying only 2 axes and talking about gyroscopes only working on 2 axes, because how does he think gyroscopes work in aircraft and that? And even your little drones, if it doesn't work in 3 axes, it's gonna go wrong.
And last 2 questions. Rocco is saying, still wants an answer to my question, please. He started then left. I was asking if the flat earther can show a city or a town over 2 miles away. If things come back over the horizon, when you zoom in, you should be able to. Oh, did we lose him again?
Yeah, we lost him again. Yeah,
and I'm I just want to say I'm sorry to the people that are seeing the 2. I'm setting up a 2-screen to make it look good, but sending it right back over to you, Mr. Sensible, to answer that if you like.
Yeah, I was just going to say this is. You're absolutely right about seeing something that far away. It's the same with the ships. If you use binoculars or a telescope, you are enlarging what is in view. It doesn't see around corners. It won't see around curves. So when half that ship is hidden below the horizon at sea, it's hidden. If you zoom in, you'll see more details. You'll enlarge what is visible, but you ain't never going to bring back what's behind the curve. Just like you're saying with a city, if it's 2 miles away and out of sight, it's out of sight. And I don't know why we keep getting them making this disingenuous claim that, you can bring ships back. Never once have they ever shown that. What they tend to do is show a horizon line where apparently there's nothing there. Zoom in and see a ship, because that ship hasn't gone beyond the horizon. It's just very far away and very small. And zooming in with the telescope or the P1000, the flat earther's camera of choice, you'll enlarge it so you can see some details. But if the bottom half's gone, the bottom half is gone, and you ain't never bringing that back.
Woohoo! Thank you so very much, Mr. Sensible. And I will let this be answered by you as well. The last question of the night, unless I can see any others, from Amber Ray. The atmosphere is contained. Does it curve around the Earth?
The atmosphere is contained by gravity. And so, yeah, it conforms to a sphere around the Earth. If it wasn't there's no problem with not having a physical container, because as we've seen, there's no physical container between the atmospheric pressure at sea level, 14.7 psi, and the atmospheric pressure at the top of Everest at roughly 2/3 that. But the air doesn't suddenly all rush up there because it's all pulled downwards. They are, as much as Nathan Oakley doesn't like to think of it, those molecules of air are behaving like little bouncy balls flying around everywhere. To go up higher, they need to expend energy. If they lose too much energy on the way up, they'll start falling back down again. However, some molecules have enough energy to achieve escape velocity. And as Brian actually got right, we lose about 90 tons of air a day, but there's rather a lot of it. So it's not going to be a problem for a very, very long time. And Mage went up there, and 99.3% of the atmosphere was not there. So what is stopping that 99.7 from trying to equalize with the 0.3 that was up there where Mage was? The answer is gravity. Desert File is absolutely right. Gravity. I don't know what else to say to that.
No, thank you so very much. And that is actually going to conclude our open discussion. I thought it was some really fun back and forth.
Shut up and sit down.